You need to learn all about Excel data analysis? You landed on the right video. Video number 4 in Microsoft 365 Excel, the complete story. And this is going to be a crazy video. You're not going to believe it. All of these tools taught in one video. That's right, sort, filter, flash fill, Power Query, pivot table, charts, Power Pivot, and even Power BI. That means this is one video to get an introduction to every one of these tools. Now, MECS video number 4 is 3 hours and 43 minutes long. That means there's everything in it, one-stop shopping. But guess what? Below the video, you should probably click More and use the time hyperlink table of contents. Now, this is from video number 3, so this is only an hour. And at the bottom, there's also this visual time hyperlink table of contents. Now, of course, each video in this class has PDF notes. You got to be kidding me. 32 pages? If we click on example 1, we're going to start it off by learning some cool tricks about sort, filter, and flash fill. Number 4, we'll see one of the greatest uses for a pivot table, summarizing survey results. 5, we'll see how Power Query can go from a website that downloads a CSV file, and we have to do some crazy transformation to get just the file we want. And then later, we simply click refresh, and everything updates. Example 6, we're going to have 12 different tables, but Power Query will have no problem converting it to a single table and calculating sales for us. And we won't load this to the Excel worksheet. We'll load it directly to a pivot table and make a report and chart. Example 7, we'll have to look at XLOOKUP function because sometimes worksheet formulas helps you get to your final pivot table and chart. In example 8, we'll get an introduction to Power Pivot and DAX formulas because we have a bunch of different tables all working together to create these reports. Then once we create our data model in Power Pivot, we'll send it automatically over to Power BI Desktop to get this amazing interactive dashboard. And the data model in Power BI Desktop will look almost exactly the same as Power Pivot. Then in our final example, we'll import 7 million rows of data from an SQL database and make 2 dashboard reports. And this is our final data model with 4 different DAX measures. Here's the download link at the Highline College website. This link is also below this YouTube video. Right-click, Save Link As. Here's the folder on the desktop that we've been using for our other files. That zip folder, click Save. There's the folder path. Right-click, Extract All. Click Extract. Then on the left, I'm going to open it up. Select it on the left, and there's all the files we're going to use in this video. Yes, we have 10 amazing examples. And since this is about data analysis, we have a lot of files. Now, below the YouTube video, there's this list of the 10 examples with a time hyperlink table of contents. So you can jump to whichever example you want. Now, on data analysis, let's just remind ourselves what we learned in video number 2. Data analysis is when we convert raw data into useful information to gain insight and make decisions. There's lots of synonyms. Data analytics, business intelligence, data science, data analysis. In every single example, we'll start with data. Data into information to make decisions, or data into information to gain insight. And don't forget, almost every single one of the tools that we use require a proper data set. Now let's go over to sort, filter, and flash fill. Now, the amazing thing about sorting and filtering, and this is an Excel table, is these drop downs in this user interface for sorting and for filtering. It's the same in all the tools. This is an Excel table. Pivot tables, Power Query, Power Pivot, and Power BI Desktop. They all use the same conventions as we have over here in the Excel worksheet. Now, to sort means to organize records in a table from smallest to largest, or A to Z, or ascending, or the other option, biggest to smallest, Z to A, or descending. You can also sort by fill color and font color. Now, the most important thing about sort is if we decide to sort on this date column, all of the records will remain intact. That means this field here will be sorted, we'll do A to Z, but the sort in this column determines the sort for all the records. So if I come up and say A to Z, oldest to newest, that record remains intact, as do all the other records. Control Z. Now, we sorted by one column, but you can definitely sort by more than one column. Let's sort sales, largest to smallest. Every single record is sorted from biggest to smallest. But watch what happens when I come over and sort region A to Z. This is a second sort. This is beautiful because this field was already sorted. When I sort all the east together, they are listed biggest to smallest. And when I get to the next category, biggest to smallest. Control Z, Z. Now, if you want to sort a column or a table that's not an Excel table, up in the Data Ribbon tab, Sort and Filter group, for sorting, there's buttons and a dialog box, and then some filtering options. Now, sorting without an Excel table, you can do that. You got to have a field name at the top. Yes, I know you can highlight and force sort by highlighting something. In general, it's always best to have a field name at the top. Then we can simply click the button and it knows what to do. Also, if this is not bold and the field name is text and these are all text, watch what happens. That field name gets sorted with the records. Control Z. That's why you hear me always say in every video I've ever made about tables, if you don't have an Excel table, add some formatting to the field name at the top, because Excel is programmed to know, hey, that's a field name. Now when I do this, it works fine. Control Z. Now, most of the time when we're doing data analysis, and in particular when we use Power Query, we're going to have a method to ensure that the data type in each column is consistent. But if you have mixed data in the worksheet and you try to sort A to Z, this is the order that the types of data will be sorted in. As an example, here's a really terrible field or column of data, including empty cells. Now, instead of using the buttons for sorting, we can also right-click. There are filter and sorting options. Now, A to Z, Z to A, some other options here. But what we want is A to Z. Numbers at the top, text, true, falses, errors. And look at that. Empty cells always sort to the bottom. And they'll sort to the bottom whether you have A to Z or Z to A. Control Z. Now, let's look at filter. To filter means to show only certain records based on one or more conditions from one or more columns. And you can use any logical test, an AND logical test, OR logical test, between, and many more. And whereas sorting organizes the records but keeps all records showing, when you filter, it's going to show you only the records that match the criteria and hide the rest. So filtering will allow us to set a condition and get just the records that we're interested in. But before I show you filtering, there's a particularly helpful use for filters. And guess what? This filter feature will be in every tool. Now, imagine we just got this data set, and you're like, I don't know how many product IDs there are. Well, when you click the filter dropdown in every tool, it will show you a unique list. So instantly, I know there are 7 IDs in this column. Region, there are 6. Even in a column like this with tons of values, there is a unique list. Now, in Power Query, for example, we'll use filter to get just the records we want before we import. But when you're in the Excel worksheet, One of the best uses for the filter feature is simply to extract the records you're interested in. So imagine your boss just texts you and says, hey, I need the West records. You just come up, filter, uncheck select all, click West, click OK, and there are your records. Now you can tell that they're hidden because the row header numbers are blue and there's hidden rows. And watch what happens when we highlight and copy. Control-C, the dancing ants are having a huge party. Now those dancing ants are only dancing around visible cells. Those hidden records are not copied. Now you'd open up a new workbook, paste, and then email it to your boss. For right now, we're going to come over to West, Control-V. And there we've extracted the records for the region West. Back over here, we can bust up this dancing ant party by clicking the Escape key. Now you can unfilter by clicking the filter, clear. Also up in sort and filter, there's a clear. Clear. Now the most powerful aspect of filtering is data type specific filtering. When we click a drop down on a date, it knows it's a date. And if we point to date filters, you got to be kidding me. There's all sorts of date-specific filters. Escape for text, text filters, all sorts of important text filters. When we get over to Power Query and we're filtering Excel files, we might say we only want files that end with .xlsx. And for numbers, there's all sorts of number-specific filters, including greater than or equal to some hurdle, or this one, top 10, or you can change it. Want to see the top 5 sales? Use this filter. Now, one other important thing about filter is we can use any type of logical test. And we have a video, a couple videos ahead that talks all about logical test. But if I select West from the region column, that's filtering on one column. As soon as I jump over to a second column and say, for example, Chantel, and notice that unique list is based on that filtered column. But when I select two conditions on two different columns, this is an AND logical test. That means the record only is included if region equals West and sales rep equals Chantel. I'm going to clear this. Now that's two columns, two conditions. If you instead use one column, and I say Northwest, and in English we say and West, but this is not an and logical test. This is an or logical test. When you're selecting multiple items from one column, it's an or logical test. When I click OK, as we'll learn a few videos ahead, what's happening is I'm saying, is the region equal to West or is it equal to Northwest? And we'll use both of those logical tests throughout the rest of the class. I'm going to unfilter. Now on to FlashFill. Now FlashFill, Data Ribbon tab, Data Tools, there's the FlashFill button. This is a one-time simple data cleaning tool. If you have a consistent pattern, you can clean the data by typing an example to the right of the column of data, then clicking FlashFill or Control-E. Now let's scroll over and look at an example. Now we have a column of data here, and our task is simply to get the name in the column to the right. Now before you use FlashFill, you have to make sure of three things. The first is this is a one-time task. We're never going to have to repeat this. The second thing is we will not get more data later and need to refresh. If that's the case, you use formulas or Power Query. And the most important thing is you have to recognize a simple pattern. And this column of data has an easy, simple pattern. I want everything after the first space. Now, here's how I do it. I usually copy and paste so I don't make a typing error. Control-C. I'm going to paste this and click in the cell below. And you either click FlashFill or Control-E. I can't tell you how often I use this tool, but not as part of an elaborate data analysis project. Just when I have a one-time task with a simple pattern. Now this was everything after the first space. Over here I want everything after the last space. I type West, enter, Control E, and that is amazing. Now you have to be careful. Sometimes FlashFill will really mess things up, and it's because it cannot see the pattern. If I come over here and type 05/05/2016, when I hit enter and Control E, that is just junk. It cannot see the pattern. Now I have lots of videos at YouTube about FlashFill and how to do special tricky things to extract a date like this with FlashFill. But it's just not worth it most of the time if you cannot immediately see a simple pattern. In this case, I would use Power Query and get the text between these two delimiters. All right, so on this sheet, we saw Sort, Filter, and FlashFill. Now we're going to go over to the sheet PT and look at one of the single greatest examples of why the Pivot Table tool is so amazing. Now back in video number 2, we learned about the basics of pivot tables. And our goal here is to simply take this one column of survey data, get a summary with count and percentage responses. Now, anytime you have a data analysis project, the question is, which one of the many awesome tools to use? Now, in this case, we know we're going to use the standard pivot table. And the reasons are, we already have the data in Excel, so we don't need to import it with Power Query. We don't need to clean it with Power Query. We have a small data set, so we don't need to use Power Pivot or Power BI Desktop. In fact, if I Control down arrow, we only have about 160 records. Control Home. And the calculations we need to make are simple. All we need to do is count and do a percent of total. The standard pivot table calculation abilities are perfect for that. Now we have a proper data set, field name at the top, empty cells all the way around. So we click in a single cell in the proper data set, go up to Insert, Tables Group, and click the Pivot Table dropdown. Now we have 4 options that allow us to go get tables. From Table or Range, that's if we have a table in the worksheet. From External Data Source, that's if we have a table stored as connection only in Power Query. From Data Model, that's if we have a table or a data model stored in Power Pivot. In Power BI, that's when we have a table or a data model stored in Power BI Online. We'll get to use a number of these different data sources throughout the class. Now, because we're going to do so many pivot tables in this class, we're going to use the Alt keyboard. Alt, that brings up N for Insert. I tap N. I see V for Pivot Table, V. And we have a table from the worksheet, so we hit T. There's our Pivot Table from Range dialog box. Because this is a proper data set, it always guesses right. We want it on the existing sheet. I'm going to put it in D4, click OK. Now I'm going to grab this Pivot Table Fields task pane and drag it closer, and then resize it. In the Pivot Tables Fields task pane, we always get a complete field list at the top. We only have one field. So we drag the field down to rows, and instantly we get a unique list. Now, because this is a text field, when I drag it to values, which is where we drag fields when we want to make calculations, it will default to count. Now, if you want to change the aggregate calculation, you click in the values area, right-click, Summarize Values By. You can choose your different calculations. Now, for us, we definitely want count because we need to count how many responses there are. Now, Summarize Values By is one way to make a calculation. The other way is this amazing feature, Show Values As. Now I'm going to click Escape. We'll use that Show Values As in just a second. And I want to rename this. Just count will do, and enter. Now we want to make a second calculation that tells us the percentage responses. So we drag survey data down again to the values. Now we come over and right-click. And what we want is make sure that Summarize Values By is set to count, because as soon as you switch over to show values as, whatever you choose here is based on that aggregate calculation. And what we want is to take each individual count and divide by the column total. So that's what we're going to use. So I'm going to click % of column total. Select the top. % count, enter. That means in less than 30 seconds, we can take this survey data, and we know what the count and % responses are. Now, we'll get to learn a lot more about pivot tables in this video and throughout the class. All right, we want to go over to the sheet PQ. Now we want to talk about Power Query. And guess what? Power Query is the greatest Excel tool invented since the pivot table. And the reason why is ever since the 90s, the pivot table has been an amazing tool to build reports and charts. But we've always been missing a tool that can import the data into Excel and also fix and clean bad data. That's what Power Query does. Power Query can import data from outside of Excel, things like text files, other Excel files, databases, and lots of other locations. It can clean the data, like split first and last name into different columns, or extract a date from a date time. It can transform data, like remove unwanted columns, which is one of the things we'll do in our next task. Calculate new columns. We'll do that 2 examples ahead. Or combine multiple tables into one table. We'll do that 2 examples ahead. And then it loads the data either to the Excel worksheet, directly to the pivot table cache, or to the Power Pivot data model. Not only that, but Power Query is not just in Excel. It's also over in Power BI Desktop. So whatever you learn about Power Query here in Excel, it works the same over in Power BI Desktop. Now in Excel, in the Data Ribbon tab, Get and Transform Data and Queries and Connections. That's Power Query. There's a bunch of different connectors that connects us to different data sources. And then this will open up the queries after we create them. Just for kicks, here's a Power BI desktop file. And data and queries, those are the 2 groups that make up Power Query. Here's all our connection to different data sources. This is how we get to queries we've already created. Now we want to go over to the sheet PQ1 Info. Now in this example, we're going to have some data at a website. We're going to need to download it as a CSV file, and we'll talk about what that is. Then import it, transform it, and load it to the Excel worksheet. And in the worksheet, we'll add formulas and formatting. And then when the website updates, we'll simply click refresh. Power Query will re-import, re-clean, and transform, and update our table. Now, of course, when we're trying to figure out which data analysis tool to do a project like this, because we're importing, cleaning, and transforming, of course, we use Power Query. Now, the data we have at this website, it's student assignment score data from a particular class. Now, actually, I made this website. This is a fake website. If you click this Export CSV button, it doesn't work. And I did this because the website that I usually use to get my grade data, I can't show you that live in public. But this is exactly what it looks like over in the Canvas system. Now, this is grade data, but it could easily be a website with sales data for a company, or government economic data, or data from a 911 call center. And at most websites where you get data, there will be an Export to CSV button. Now, for our particular grading data from our Canvas website, they have a bunch of columns with a bunch of field names that I don't need. I want to change them. A bunch of columns that I don't need, both with data and some extra calculations that I don't need. Now, if this was Canvas, I just click this button, and it would download the CSV file, and then that's what we import into Excel. So what I've done is I've created 3 CSV files that will simulate. This is the first website. This is when it updates later, and this is the final update. So even though we won't download these from the website, the process is still the same. When we get a new file, we need this new data to update our project. Now, what does .csv mean? It means comma separated values. And if we right click, open with, and I'm going to open with Notepad or WordPad or Word. I'm going to use Word and then click OK. This is what you see. Each one of the field names, name, ID, quarter, is separated with a comma. And then all of the records, there's a first name, comma, ID, comma, the quarter, comma, the name of the class, and then a bunch of scores. Now, why in the world would a table of data be stored like this? Well, it goes back to the beginning of database history. Since there were so many different types of systems, we needed one method to get tables of data from one system to another. So one of the conventions they agreed on is a delimited table. Now, delimiter means what separates the bits of data. For us, the delimiter is a comma. The other type of common delimiter is a tab. We'll see that delimiter in our next example. So all a text file, either CSV, comma separated value, or a text file, which is a tab delimiter, all they do is get data from one system to another. And when Power Query sees this, it'll interpret it as a table. Now, another important note about .csv files. This computer is programmed to open up .csv files with Excel. So if I double click this, this looks like Excel, but it's not. That .csv file extension and the file structure prevents you from doing almost everything in Excel. So just be aware when you see .csv, this is not an Excel file. Now, before we jump over to Excel, we're going to do a little file management. Now, here's the folder we downloaded and extracted. And you need to make sure that all of these files are closed before we do our file management. So, for example, if you have this open, you need to go close it and then come back to Windows Explorer so we can do our file management. Now, before we use Power Query to import the CSV data into Excel, I want to look at the folder path. We're here in Windows Explorer, and if I click up in the address bar, that's the full folder path that Power Query will memorize when we import this file. Now, this is called an on-premise folder path, and the reason is this folder path is specific to the computer I'm working on. Users Girvin desktop, that's going to be unique to my computer. You will have a different beginning folder path. But the rest of it, folder name from video 1, folder name from the files we just downloaded, those will be the same. Now, if you look up in the formula bar, when we extracted, it has a duplicate folder name. To make this folder path a little bit shorter and easier to read in Power Query, I want to remove that first duplicate folder path. Now, over on the left, this is the folder we created in video number 1. But 1, 2, there's one duplicate folder. If I look inside this one, well, we're looking at this. When I look inside this one, this is the one that actually has the files. So I want to cut this and paste it into this folder right here. You can either click and drag to move it, or you can use Control-X to cut. Select the folder we created in video 1 and Control-V. And now we have a clean folder path. Here's everything inside that first folder. Here's everything inside the folder we downloaded for video number 4. Now, if I click up here, that'll be the folder path. Now, we'll point Power Query to this, and it will include that file name at the end. Now, let's open up our Excel file and start the import. So I'll double click. We're on the sheet PQ1. We go up to the Data tab, Get and Transform. Now, we can directly click from Text CSV, but all of these are connectors. And if you click the Get Data dropdown from File, it has different types of file types like Excel, CSV, XML. There are databases. Later, we'll connect to an SQL database. from Azure, Power Platforms, and many other data sources. I'm going to click Escape and click From Text CSV. In the Import Data dialog box, we navigate to our folder. There's the folder path. I select grade1.csv and then click Import. Now, it wants to help us properly import this. It wants to know what the file origin is. That's correct. This is the one you always have to check. Make sure it's the correct delimiter. For us, it got it right, and it usually does. Data type detection, the default is based on 200 rows, which usually works. You can base it on the entire data set. Now, you almost never want to click Load. You want to click Transform Data. What Transform Data does is it opens up the Power Query editor and gives us a chance to clean, transform, do whatever we need to do before we import and then load it. So let's click Transform Data. And here it is, the Power Query editor. This is a new window on top of the Excel window. And we can already see that Power Query did its magic. We have a preview of the proper data set. Over here on the left is the default name for the query. Also on the right, this is where we can rename the query. And we definitely want to give this query a good name. I'm going to highlight this, and this is for the Summer Business 101 scores, and enter. We renamed the query. We can see it listed on the left. Now, right now in the Power Query editor, we only have one query. But as we import and transform new data in this Excel file, we'll see other queries listed here also. Now, one of the most amazing things about Power Query are the applied steps. Now, there are 3 automatic steps. We can add other steps later by using the user interface, and we'll add new steps. These applied steps are memorized by Power Query. So later when we refresh, all of these steps are rerun to refresh the query. Now, watch what happens when I click on Source. It gives you a preview of what it did in that step. That means we can look at each one of the steps. It memorizes what it did. That's really different than in the Excel worksheet. When we do something in the Excel worksheet and have a progression as we're building something, we can't go backwards like this. So in the first step, it got the data in records. But notice the field names are in the first row. And the column headers, column 1, column 2, are default field names. When I select the next step, I get a preview. Sure enough, it promoted the headers. Now, the last step is change type. And before I give you a preview of that, in the name column, it says ABC. That's the icon to say this field has a text data type. If we click ABC, a drop-down appears, and these are the different data types that we can use in Power Query. Decimal number, that's up to 15 digits, like in the Excel worksheet. Currency, that will apply currency but only allow 4 digits. There's a whole number. That will show it as a percent, date, time, text, true, false. And binary, as we will see later, that allows us to actually have files in a column where we're allowed to do things like combine tables. Now let's scroll over. And so here's test 1, ABC. We can see the alignment to the left. That tells us it's text. But when Power Query applied change type to all the fields, it usually guesses right. In this case, because there were no decimals, it chose the whole number data type, which shows as a 1, 2, 3 icon. You can also tell that these are numbers, of course, because they're aligned to the right. So these applied steps, the automatic ones and the ones that we're going to add later, this is the foundation of a Power Query query. But behind this foundation is an amazing Power Query functional language called M code. And Microsoft says the M in M code means data mashup. That means to bring lots of data together and mash it up into the proper form. Now, Power Query with the automatic steps and when we use the user interface to add new steps, Power Query writes all that code for us. Now you can write your own M code, but most of the time you don't need to. I will show you how to write some M code though when the M code we can write is better than what Power Query can write. Now I gotta go show you where to look to see that M code because it is a thing of beauty that Microsoft created. Now first, there's applied steps. But second, when you click on any particular applied step, look up in the formula bar, and you can expand the formula bar. Look at the names of the functions. csv.document, file.contents. That is amazing. Microsoft named all of these M code Power Query functions with really easy to understand names. And there's the file path. If we go to promote headers, sure enough, they named this function smartly, table.promoteHeaders. If we click on change type, table.transform column types. So we have applied steps. And then in the formula bar, we can see each particular step and the M code that's created. But now I want to show you the third place to go and look. And notice that's called source. There's the formula. That's called promote headers. There's the formula. If we go up to, in the Home Ribbon tab query, Advanced Editor, let's click. Here's the Advanced Editor in a new window. And this is all the official M code. It always starts with let. There's the name of the step, then an equal sign, and then the formula. Now notice, this first step, we were allowed to go look at it. It's called source. When we click in the applied steps over here, it shows us the result of source. At the end is a comma. And then, of course, the next line, there's the name of the next step. Now, why is there a pound sign? Well, because in Power Query and in Excel also, we know that any text is in double quotes. So if this name just used double quotes, Power Query would think it's text. So when they created M code, they said, hey, when we put a pound sign on the outside and then double quotes, that means it's an official name for an applied step. Now, source does not need the pound and double quotes because there's no space. So second step, equal sign, table.promoteHeaders, a comma. Now the other amazing thing, step 1 is named source. But what does the next step do? Promote headers, it works with that. So for automatic steps, and when we use the user interface, the first argument of the next function is always the name of the previous step. Comma at the end, change type, table.transform column types, and sure enough, there's the name of the previous step. Now when it gets to the last step, what? There's no comma. That's because in and repeating the last step tells Power Query this is what it's going to deliver as the final value. In our case, it's a table with promoted headers and changed data types. We can click Cancel. Now, the majority of the time, all we need to do is just look at applied steps. But now you know, applied steps. See the formula in the formula bar, Advanced Editor to see everything. All right, now that we've had a complete preview of the magic of Power Query, let's finish cleaning and transforming this table. Now, if I'm going to do a step, I definitely don't want to have source selected. I want to act on the last step, so I select Change Type. Now, our first goal is to remove some columns. We do not need quarter and course number. And there's some columns at the end we don't need. The easiest way to do that is up in the left-hand corner, there's a drop-down. We click and select Choose Columns. This is especially nice when the table has a lot of fields. We don't need quarter or course number. We don't need current, any of these calculated columns at the end. Name ID, all the tests, all the quizzes, we're good to go. Click OK. There's our new step. Table.select columns. Well, that's a smart name. Notice the first argument contains the name of the previous step. Now, just if you're curious, of course, if you go up and look, the new last step better not have a comma. And there it is. And it doesn't. And the previous step has a comma. Cancel. Now we need to rename some of these fields. I don't want the summer 22, so I'm going to double click test 1. I'm going to not have a space and enter. It adds a new applied step, table.rename columns. We could look at the function. Notice it's acting on the previous step. And there it is. There's the old field name and the new field name. Now you can keep this open while you rename the field. So I'm going to double click test 2 with no space and enter. And sure enough, there it is. And in Power Query, curly brackets mean a list. And notice there's a list within a larger list. Each one has the old field name and the new field name. We will continue on test 3 and enter. Test 4, enter. Quiz 1, enter. Quiz 4, that's the last one, and enter. Now we can close the formula bar. And our last task is we're going to have to add data types. Now I don't want whole number 1, 2, 3. I actually want decimal in case we get future scores that are decimals. Also, quiz 3 and 4 have a text data type. So when we get numbers later, those numbers would not work. So we want to change the data type. And we absolutely could select the last type and do it one column at a time. But I want to be efficient. And not only that, we have this previous step that already changed the data types. So what I'm going to do is I'm going to delete it and just redo it down here. That way we're being efficient. The fewer steps, the more efficient it is. Now you can hover and use the red X, but you got to be careful when you're deleting a step. If this step would adversely affect the subsequent steps, you don't want to do it. But changing the data type has no effect on removing columns or renaming columns. So I'm going to delete this. And this warns you, deleting this step may affect subsequent steps, but it's not going to have any effect on subsequent steps, so we delete. I select the last step. I'm going to start at the beginning, click on Name, hold Shift, click on ID. And instead of doing it one at a time, right-click, change data type, and we'll go down to Text. Now we select Test 1. All the remaining fields are numbers, so I scroll over, hold Shift, click on the last one. Right-click any one of the field names, change type, and we want decimal. And there's our new step, table.transform column types. We see nulls in these columns. That's what Power Query uses instead of showing an empty cell. Now we've done all of our transformations. We have our steps. It's named. And now we're going to load our table to the Excel worksheet. In the Home tab, Close Group, we click the Close and Load drop-down. If you click the button or select this first option, it does the default. It loads it as a table on a new worksheet. If you want control over where you load it, you choose Close and Load to. By the way, the close means it'll close the Power Query editor, and load gets us to the next dialog box. So I click. Here's the Import Data dialog box. If we select Table, it will load it as an Excel table. We can also check Pivot Table Report. It'll put it in the Pivot Table cache, or Pivot Chart. That also goes into the Pivot Table cache. If we select Only Create a Connection, it doesn't load it to the worksheet as a table or in the Pivot Table cache. If you leave it just like that, it just stores the query in the Power Query editor and doesn't load the data anywhere. Later, when we use Power Pivot to load it to the data model, we'll select this because we don't want it in the worksheet, and then check this so it goes to the data model. For us, we want Table, Existing. I'm going to select C4, and when I click OK, there's an Excel table loaded to the worksheet. Now, when you load a query over on the right, the Queries and Connection pane always comes out too small. So we have to widen the task pane. Queries and Connection That's this button right here if you don't see it. Now notice there's the name of the query. If we hover, we get a preview. We can see how many columns. There's the load status. It tells us it's in the worksheet. But later when we load it to the data model or a pivot table cache, that's a helpful hint about where it was loaded. And there's the file path. Now the name of this query is Summer Business 101 Scores, but that's the query object. We also have an Excel table object here, and it has the same name. If we go up to the name box in the formula bar, sure enough, that's the same name. But that's the name of the Excel table object. And it makes sense that a query object and table object have the same name because they're related. In fact, anytime we want to edit or change this, maybe we made a mistake, we can just open the query, change it, and reload it. In fact, what I really wanted to do is I wanted to split first and last name and then sort the table by first name. So let's go do that and then reload the query. To open the Power Query Editor, double-click. Our goal is to split this column, but I want the Change Data Type step last, so I'm actually going to X this out. I have the last step selected, so now I select Name. I can go to Home, Transform Split, or right-click, Split Column. We want to split by the delimiter space. Now it guesses right, and we only have one space here, so any of these options will work. When we click OK, now we have split one column into two columns. There's our new step. And look at that. It added an automatic change type. Now, I don't want that because I want to manually do this at the end, so I'm definitely Xing this out. There's actually a setting in File Options to turn off automatic data types. Now, the next task is to rename these. And by all means, we could select the last step, double-click, and rename. But this is one of those situations where if we look at the M code in the formula bar, we can probably figure out what's going on. Table.split column. There's the name of the previous step. There's the original name. It has this big function that actually did the splitting. But look at that. There are the new names. And it's in a list. So we can simply edit the M code. Selecting name 1, we'll type first name. Selecting name 2, last name. And now when I hit Enter, I did that again. I'm going to X this out. But sure enough, we did some M code editing, and now we have first and last name. Now we need to move last name to the first column, so we can click the field name and drag it over. There's a new step. Now we come to the Filter dropdown, and look at this. Sort and filtering looks just like over in the worksheet. I'm going to select Sort Ascending. And now we have accomplished our task. Two different columns sorted correctly. I see all of the steps. We want to add our last step. I select last name, hold Shift, ID, right-click, change type, and text. Select test, scroll over, hold Shift, select quiz 4, right-click, and we'll change this data type to decimal number. Now we have all of our steps. Everything's looking good. We come up to close and load. This is grayed out because we've already loaded it. So all we have to do to reload is click the Close and Load button. When I close and load, that is a thing of beauty. We have updated the Excel table by editing the query. Now next, we want to scroll over, and we want to add two new fields, one for total score and one for percentage grade. Now anytime you're making calculations like this in a column, you have a choice. You can use worksheet formulas, or you can do them back in the original query. Either way is fine. Sometimes people are more familiar with a worksheet formula, so they like to do it that way. But in our next example, I'll show you how to create a new calculated field in the query before we load it to the worksheet. Now this is going to be called total score. So when I type a field name, it adds a new field to the Excel table object. Percent grade and enter. I'll change the column width. Now before we do our formulas, up above, I'm actually going to list the maximum scores. So 100, 100, and then for the quizzes, 30 and 30. That way we can add up the maximum points for assignments and use that in the denominator for our percentage grade. So max scores, I'll enter some data and some formatting. Now I went ahead and added some formatting, the numbers for the completed assignment, and then we want to add them. So I hit enter. So far, the maximum total points possible in this class are 260. Now I want to add the total score for each student. Alt equals, and I'm going to redirect it, test 1 to quiz 4. Notice this is a table, so it lists the name of the table. There's the implicit intersection operator, which makes this a relative range of cells. As the formula is automatically copied down, the range will move. And then it shows, instead of a cell reference colon cell reference, it lists the field name colon field name. So when I hit enter, there's the total scores. Now we can build our percent formula equals left arrow, and there's the syntax for relative cell reference, divided by, and this is a cell outside the range. So I have N2, and we need to lock it. So we hit the F4 key. When I hit enter, the formula is automatically copied down. And in each cell, we compare accumulated points for the particular student compared to the total possible. 133 divided by 160, 0.51. 257 divided by 260, 0.988. Now we can display this as a percentage. Highlight, Control 1, percentage, 2 decimals, click OK. I'm also going to add some style formatting. Right-click, mini toolbar, and then some borders. So what we've done is we created a query and loaded it to the worksheet, and then added formulas and formatting. Now let's go look at the updated website. Here it is, test 3 has been posted. Now this is our fake website, but what we would do is click CSV and download the new file. Now there's 2 ways that you can download the file. And the way that I usually do it when I download grades from Canvas is when I download it, I replace the old file using the same name. That way, over in Power Query, all I have to do is refresh. But if you want to keep a historical record and at any time be able to show any one of the sets of scores, then you download the files and name them differently. That's what we're going to do. We're going to go over to Power Query and say, hey, Power Query, don't look at grade 01, look at grade 02. Now in Excel, there are 2 good ways to update the data. The first way is let's edit the query. Double click, and in the source step, you click the gear icon. This dialog box allows you to browse. So you click Browse. You find your file selected, click Open. I'm going to click Escape. That is one way to do it. The other way to do it is in the Data ribbon tab, Get Data, Data Source Settings. Now I like to do it this way because over in Power BI Desktop, this is very similar to how we do it. We open up Data Source Settings. We may have many connections to many different data sources. We select the one we want and click Change Source. Here's the same dialog box. I click Browse. Select File 2, Import. OK. Close. And we do have to refresh. You can click the Refresh button there, or you can right-click the table, Refresh. And just like that, I have the new scores. I come up here, type 100, and Enter, and everything's updated. Now what if we get yet more scores? Well, let's go up to Data Source Settings. Select the source, click Change. And instead of browsing, guess what? There's only a 1-character difference. So I'm simply going to add a 3 here, click Click OK. Click Close. Right-click Refresh. Add the 30 at the top, and everything's working. All right, so in this example here, we used grade data, but by all means, you might be getting sales data or government data from a website using a CSV file. We saw how easy it is to get Power Query to import it. We can clean and transform it, load it to the worksheet, and update later. Now we want to go over and look at our next example. I'm going to click on the sheet PQ2, PT Info. Example 6. This is going to be one of the best examples in the entire video. And the reason why is business people for decades have had to take multiple files with monthly sales data, combine them into a single table, make their monthly sales report, and plot the results. But the problem is, for decades, this has been a horrible manual process. And when you get new data, it was always very difficult to update the solution. But then came Power Query. Power Query has no problem importing all these text files, combining them into a single table, calculating sales. Then we load it directly to the pivot table cache, and the pivot table is suited perfectly for these types of calculations. And then we plot it with an Excel chart. Not only that, but if we start with 9 months of data and create our solution, all we have to do is drop whatever new monthly files we have into the folder and click refresh, and everything will update. Now looking inside of our example 6 folder that we downloaded, we have 9 different text files. Now I want to open one of these up. Right click, Open with, Word. Now I opened it in Word because in the Home tab, Paragraph, I want to click the Non-Printing Characters button. And now you can see the delimiter. That arrow in Word means a tab. This is the second common delimiter besides a comma. And you can see we have 1, 2, 3 fields: date, units, and price. When we get over to Power Query, we'll combine all 12 of these, and then more easily than in the Excel worksheet, we'll get Power Query to multiply these 2 columns and create a sales column. Now starting on the sheet PQ2 Pivot Table, we're going to go up to Data, Get and Transform, and the Get Data dropdown from File. And this is without a doubt one of the most amazing things that Power Query brought to Excel. We can tell Power Query to get everything from a folder. So we'll click, and we navigate right down to our folder. We're not going to see anything from inside of it because Power Query is just going to look in this folder and take everything that's in it and bring it into the Power Query editor. So we click Open. There's a preview, and this is different than our last example. This is a table, but binary means there's a text file, which to us is a table in each row. All of these fields here are attributes for that file. This is just like you would see in Windows Explorer. Date access, date modified, the folder path. And also, very importantly, we'll have to use this column here, the extension. Now we click Transform Data. We can see on the left we have 2 queries now. We immediately come over and rename this. I'm going to call it Many Files into One Table and Enter. There's our source step. Up in the formula bar, there's the function folder.file, and there's our folder path. Now this content column contains the text files. Now if you click off to the side, don't click directly on the word binary because that will extract just that one file. But off to the side, we can see this icon preview of January, February, and so on. So that means in this content column, we have a column of tables with the same structure. Field names at the top, records and rows, all with a tab delimiter. That means with Power Query, we can easily combine these into a single table. And the way you combine the files, I'm hovering over this double downward pointing arrow button. It says Combine Files. Now you need to be careful. Binary just means there's a file here. If these were Excel files or database files, and the table object in each row did not have the same structure and delimiter for every row, then this button would not work. So that's when you use this button, only when the tables have the same structure and delimiter. Now, before we use this button, we want to think about the fact that Power Query is pointing to a folder and getting all these files. Now, right now, it looks like all of the files are text files. But what if we accidentally put an Excel file or a database or a Word file in that folder? Then if we tried to combine, it wouldn't work. Now, the best way to deal with this is just to make sure that there are only text files in this folder. But if there might be some other files, there's an easy way to prevent those files from appearing in this column. And it's by using the extension field. If we use the filter option to only include files with a .txt, that would solve the problem. Now we have to learn something really important about Power Query M code. Power Query M code is case sensitive. That's different than the Excel worksheet. Almost everything in the worksheet is not case sensitive. But in Power Query, everything is case sensitive. So it looks like some of the files come out capital TXT and some lowercase. So if we're going to filter here, we're going to have to say, hey, include that possibility, this possibility, and so on. But we don't have to do that because Microsoft knows that, and so they offered an option. Let's right-click the extension column, come down to Transform, and sure enough, there's an option to transform everything into lowercase. So when I do that, now we only have to filter to include .txt lowercase. Now it added this new step. Now we come to add a second step down to text filters. I want to say only equals. And because we thought ahead and made everything lowercase, that's all we have to do. Click OK. Now we're ready to combine. We want to remove all the attribute columns first. So I come to Content, right-click, Remove Other Columns. And there's our step. Now we're going to click this button. And when we click this button, it is going to do a lot of things for us. It's first, when we click it, it's going to ask us some important questions. Now, because there's a lot of files here, Power Query is just going to use one of the files to build all the code for us. So it's saying I'm picking the first one. Here's the file origin. Make sure the delimiter is the correct one, and it is, tab. Based on the first 200 rows, that is fine. Now, when we click OK here, Power Query is going to build all sorts of new queries for us. All of these queries were automatically built and then used to get this one final table. That is a thing of beauty. Now, we don't really need to know about all of this because we were sure that all the tables had the same structure. But what it did is it took a sample file, built a parameter, which is a variable, then from one file transformed just one of the files. Then it built a custom function. And down in our final table, it added a bunch of steps, including invoking that custom function. Simply amazing. Now, the last step we need before we load this is I want to multiply units and price in a new column. So watch this. We can select the column, hold Shift, click on Price. I've selected two columns, and I want to add a new column. So I go up to Add Column. There's all sorts of amazing ways to add columns. But from Number, we click the Standard. And when we click Multiply, notice we're clicking something in the user interface. It'll build the formula for us. There's nothing like this in the worksheet. So we'll click Multiply, and sure enough, it took 3 times 21.95 and got 65.85, and then did that for every row. Now here's the new step. Let's look at the formula in the formula bar. Table.addColumn, it's definitely acting on the previous step. Multiplication, that's the new name. And then for each row, units times price. And in the last argument, it was polite. It added data type decimal. It's called number, but that means decimal. Now, we definitely want to rename this. So instead of double-clicking and adding another step, we're going to be smart. We're going to write better M code than adding a new step. We could tell that in the second argument, that's where it named this field. So I'm going to double click and call it sales and enter. All right, so now you can say you've actually written your own M code. Let's close this. We have all of our steps. We are ready to load this. Now let's go up to Home, Close and Load dropdown, Close and Load to, and the Import Data dialog box. We do not want to load it as a table. And the reason why is we're never going to use that table for things like filtering, sorting, or making other formulas. So why duplicate the data source by putting it into the table and then making a pivot table which stores it in the pivot table cache? In this case, when you don't need the table and you want a pivot table, that's your selection. We want to put it on existing C4, click OK. And even though I don't have a table in the worksheet, it is in the pivot table cache. Now let's build our pivot table. We'll drag date down to rows, and of course, instantly it will build a bunch of extra columns in the pivot table cache. I don't need date. I don't need days. I see months. That's what I want. Let's change the column width. And I'm going to click up on the formula bar just because it was my cursor was close. Change that to months. I drag sales down to values. I get sum of sales. In the header, I'll put in parentheses a $sign to indicate the unit. And then this is a standard pivot table. So in the values area, right click, number formatting. When I use the format cells with a single number tab, I'm formatting the actual field. So I'll say number, comma, and I'm going to show 0 decimals. I don't need to see the pennies. Click OK. Now we need to show the month over month change, and then the percentage change, and then percent of total. That's where show values as comes in. We drag sales down a second time, right click. And summarize values by has to be sum because we want to see the change in total sales. So the aggregate calculation is right. So we come down to show values as, and there's this amazing difference from. So I select that. It wants to know difference from what? Well, of course, I want the month-to-month difference. And when you're doing month-to-month difference, sometimes accounting reports require everything based on January, but that's definitely not what we want. We want the previous. So previous means when I get to this line right here, I'm going to take the difference between this and the previous. When I'm down here, the difference between this one and the previous month. I click OK. And if you do the subtraction off to the side, 520 minus 671, you're going to get minus 150,000. Right click, number formatting. We'll show it all in 0 decimals. This will be called change with a $sign. Now we drag sales down again, right click, summarize as sum. So we go to show values as and percent difference from. Months, previous, click OK. And that calculation is polite. It adds the number formatting. Up here, I'll type percent change and enter. And then we want one other calculation. I want to compare each one of the individual monthly amounts to the total at the bottom of the column. So I drag sales down to values. Right click, summarize as sum. So I do show values as percent of column total. Percent of total sales, double click. I'm going to change the number formatting on both the percent columns to show 0 decimals. Now what we want to do is go add some files to the folder and refresh this report. Remember, that query right there is looking into that folder. So when we refresh, it'll bring in all new files. Now here's October to December. So I click on the first one. I hold Shift. I click on the last one. And I want to put in some files that are not .txt. We want to test our theory. I'm holding Control key to select items not next to each other. We'll do a PDF and a .csv. Copy those. Select the folder, Control V. All right, so these should make it into the report showing us October, November, December. And these extra files should have no effect on our report. Since we loaded this directly to the pivot table cache, all we have to do is right-click, refresh the pivot table. And just like that, that is absolutely amazing. In addition, let's go look at the query, double-click, and we have our one table. Let's look at source. And if you don't see everything here, you might have to click Refresh Preview. But sure enough, it got October to December .csv and the PDF. And if we look at our filtered rows step, and sure enough, our filter, which was protecting our report, worked like a charm. I'm going to close this query editor. Now we want to make an Excel chart. Control and roll to zoom in. However, when you create a pivot table with multiple calculations, if you point a chart to this pivot table, it will include all the calculations, and you can't remove them. Now, that's different than if we built this with formulas. If you build a formula report with many different columns, you can pick and choose any of the columns for a chart you're making. But no problem. We're going to highlight this, and I'm going to copy the entire pivot table. And then off to the side, I'm going to select I4 and Control V. I want to point to the Smart tag and say Keep Column Widths. Scroll over, click inside the pivot table. I see queries and connections, but let's go back to our pivot table task pane. And I'm simply going to drag the calculations off, except for the one we want for our chart, sum of sales. By the way, if we didn't copy and paste that pivot table and you wanted to access the data in the pivot table cache, you could go up to Insert, Pivot Table dropdown, and that's what this option is for, from External Data Source. I click, you have to choose a connection, and then there's the query and the name of our table. So you'd select that, click Open. But we have our pivot table here. With a single cell in our pivot table selected, we go up to Insert, Chart Group, and we're plotting values in a time series across consecutive months. So the perfect chart is Charts Line Chart. Let's do the one at the right here with the marker. So I click. Now we don't need these field buttons, so right-click, hide all field buttons. This is chart junk. It's not adding anything. A legend really doesn't help unless you have more than one series of numbers. So I'm using the delete key. Up above, I'm going to create a chart title. Something like company change and monthly sales. I select the chart title. When I see the solid line, I type an equal sign. That shoots me up to the formula bar. I select the cell. I see the formula. I hit Enter. With the move cursor on the outside edge, I'm going to click and drag. Now I'm going to hold Alt to snap to the grid. Now let's move holding Alt so we snap to the grid. Now I want to add some percentages, and conveniently we're going to steal them from this other pivot table. Chart elements, green arrow, data labels, and when we click more options, it opens up the correct task pane. We'll uncheck both of those, and we want values from cells. We'll get percent change. Click OK. Check values from cells. Down here, label position, we'll say above. Now for the vertical axis, I'm going to select it, Control 1, and in the task pane, we're going to say display units. And I'm going to say in thousands. Actually, this is a pretty new feature in Excel. It's been over in Power BI Desktop for a while, but that's looking good. So we have our visualization and our report. All right, in this example, we saw how to go from 12 files, use Power Query to combine them, create a sales column, load it to the pivot table cache, create our report, and then our visualization. All right, we want to go over and look at our 7th example on the sheet VLOOKUP and PT. Now in example number 7 and 8 and 9 also, we're going to have 3 different tables. And from the 3 different tables, we're going to need to create reports and visualizations. Now in all 3 examples, we have what's called a data modeling problem. our table does not have all the correct columns we need to create our final data analysis solution. If you look at sales rep ID, these are numbers, but I need to look up each one of these numbers and bring over the sales rep name. Same with product. I need to look up each number in each row, bring over the correct product name as a new column. Once we have both sales rep name and product name, then we can build reports that actually have the name or down here the product name. Now, we could make the reports with sales rep ID and product ID, but then the reports and visualizations would not be as user-friendly. Now, anytime you're trying to build reports and visuals from multiple tables and you have a lookup situation, there's a number of different ways to solve the problem. Now, the first way is to use worksheet formulas. We're going to add 2 extra columns and use the XLOOKUP function to look up the sales rep and product names. Now, when is it appropriate to use worksheet formulas? Well, if you have the data in the Excel worksheet already and control down arrow, you don't have a lot of data. 43,000 rows is not a lot of data. Control home. And our data analysis solution can be sufficiently created with PivotTable reports and Excel charts. Then we can go ahead and use worksheet formulas, have one table, and then make our reports and visuals. Now, example 8 and 9, we're going to have the same tables. Let's go look at this sheet RDM DAX. Example 8, we're going to have the same 3 tables, but they're going to be coming externally from an outside Excel file. So we're going to use Power Query to import. And instead of loading it to the Excel worksheet and creating almost 100,000 formulas, we're going to load it directly to the Power Pivot data model. That allows us to build relationships between the tables and then actually build data model pivot tables based on multiple tables. Now, we choose this approach. Of course, we're using Power Query because we're importing, but we choose Power Pivot because in the data model in Power Pivot, it allows us to create relationships between tables and avoid all those XLOOKUP formulas in the worksheet. And later we'll see another reason for using Power Pivot or Power BI Desktop is if you have a lot of data, Power Pivot and Power BI Desktop can deal with big data much better than the worksheet. Also, we'll get to see that Power Pivot and Power BI Desktop allow you to create reusable pivot table formulas called DAX measures. And then in example 9, we'll have the same data source. We'll use Power Query inside of Power BI Desktop, load it to the data model there, and make data model Power BI visuals and dashboards. Now, when do you use Power BI Desktop instead of Power Pivot or the Excel worksheet? Well, the most amazing thing about Power BI is that you have interactive and shareable visuals. All right, let's go over and start the XLOOKUP PT example. Now we have our 3 proper data sets, and I've already converted the first 2 to Excel tables. This table is named F Transactions. This one is named D Sales Rep. Let's click in the product table, Control T, and then Enter. Immediately come up to Table Design Properties, and we're going to call this D Product. Now, why the D? The D is for dimension. And this is a dimension or lookup table. These contain the attributes that we want to come over in our new columns that will serve as conditions and criteria in our reports and charts. Now, there's a very important characteristic to lookup or dimension tables, and that is the first column of any lookup or dimension table must have a unique list, and both of these do. And the reason why is simple. Over here in the sales rep ID column, we have many repeats, 333, 55, and so on. But for a particular row, when the lookup formula is going to look up 3 and try and find a match, if there were duplicates, it wouldn't know which one to bring back. So dimension or lookup tables always have a unique list in the first column. And then attributes or characteristics that can be used for conditions or criteria for making some summary calculation, or other characteristics such as a product price that you might look up and use in a formula. By the way, this one, F transactions, the F means fact, because these are the facts that we're trying to summarize. Now, we're going to use Excel tables. We don't necessarily have new data we're going to add later, but that's the main benefit of Excel tables. If we add data later or new products, everything updates. Also, as we have seen before, when we add new columns, the columns are automatically incorporated into the table object. And also, the formulas we create are going to be easier because we're going to use table formulas. Now, this new field will be called sales rep. And of course, when I hit enter, a new column is added to the table. Now, we need to look up 3 here, 5 here, 4 here. And in each case, we need to get a match in the first column and then go over to our second column and bring back that value. Now, in the old days, we used the VLOOKUP function. But that is a function from the past. It's much more difficult to use than the new amazing XLOOKUP function. Now, our goal is to put a lookup value, that is, what value we're going to take and try and match in the first column. So I select that cell. That's a table relative reference, comma, lookup array. That's which one of the columns or fields has the items that we're going to try and match based on the lookup value. Well, it's that one right there, comma, return array. Those are the values that we want to bring back to the cell. Now, this is an Excel table, so I should have clicked at the top with my downward pointing black arrow, and that puts the column reference in. Now, there are a bunch of other arguments in XLOOKUP. We have a video all about lookup functions a few videos ahead. So we'll learn all about these arguments in that video. But for doing an exact match, where you're trying to exactly match something in the first column, you just need lookup value, lookup array, and return array. Now, this formula will automatically copy down because it's an Excel table. That's a relative reference. But when we highlight entire columns, those are locked as the formula is copied down, which of course is what we need. Close parentheses, and when I hit enter, wow, I've added a sales rep attribute column that I can now use as a condition or criteria to help do some summary calculation. Now let's do the same thing over here. This would be called product, enter, equals XLOOKUP. I'm going to arrow over. There's the relative cell reference, comma, lookup array. I click at the top of the product ID column in the lookup or dimension table, comma, return array. Those are the items that I want to go and get. So I select that field, and there's our formula, close parentheses, and enter. Now, if this is 43,000 rows tall, 43,000 times 2 is almost 90,000 formulas. Now, Excel is going to have no problem. This is a small data set. But if you really did have 100,000 or 500,000 rows, we would be switching over to Power Pivot or Power BI Desktop. That much data is handled much better with those tools. Now, the rule I use is about 50,000 rows is the max I put into an Excel worksheet. But the worksheet does have 1 million rows, so you can add a lot of data here, but things tend to slow down when you do that. Now we have our one table, and when we add columns like this from dimension or lookup tables, this is called a flat table. And all that means is we have one table. When you have one table, you can use what's called the Standard PivotTable from Table Range. Now, the Standard PivotTable is the PivotTable tool that works with one table only and uses summarize value by or show values as calculations. A data model pivot table, which we'll see when we use Power Pivot, is a pivot table tool that works with multiple tables and uses DAX formulas to make its calculations. Now, I'm going to use the keyboard with a single cell in our one flat table, Alt-NVT. Now I'm going to put this pivot table on this sheet to illustrate the reports and charts and tables all together. Normally I'd put it on a different sheet. Clicking in cell K19, click OK. The first one is sales rep. So we're going to drag sales rep down to rows. Instantly we get a unique list. We're going to get the sum of sales, so we drag sales down to values. Right click, number formatting, number, comma. We'll show 0 decimals, click OK. Now I go back over, click in a single cell, Alt-NVT, existing. I'm going to put this one in N19, click OK. Region, that was an attribute that was already in the table. We drag it down to rows to get a unique list. Drag sales over to values. Right click, number formatting. Now I want you to notice something. We are using the sales field in multiple reports, and every time we have to add number formatting. That's just the way it is with the standard pivot table. When we use Power Pivot or Power BI Desktop and create data model reports and visualization, we won't have to repeatedly add number formatting because you can add number formatting to a reusable DAX formula. But with the standard pivot table, you have to reapply the number formatting each time you use the field. Click OK. Come back over to the table, Alt-NVT, existing. I don't want to put it directly next to the table, and I definitely want to put it at least a few rows down. I'm going to select K29, click OK. Product, I get my unique list. Sales, down to values, right-click number. We'll add number, comma, 0 decimals, click OK. Now this one we're not necessarily going to look at. We're going to make a chart from this. And anytime we have categories like this and we want to compare the amounts across these categories, the perfect chart, insert, charts, is not a pie chart. Research shows that it's harder to tell the differences between the amounts with a pie chart. The preferred chart type for comparing amounts across categories is either column or bar. Don't use the 3D. That's mostly chart junk. Bar chart is a good choice when you have very long labels, otherwise column. Now we'll talk about some of these other two-dimensional columns and bars in our upcoming dashboard and visualization video. For the time being, we're going to select clustered column. Right-click the field buttons, hide all field buttons. We'll remove this chart junk, delete. I'm going to move this temporarily over here. Right here, product sales total, and I'm going to indicate the unit, and we want to show these in thousands. So at the top, I'm going to indicate that in the chart title. Here's the chart title. Equal sign, that shoots me up to the formula bar. Click on the cell and enter. Now I would like to show the amounts at the top. So we come over to our green plus, data labels. And actually for this one, we can just click data labels. Now let's do a little trickery because here we have chart junk, right? We probably don't want both of these, but I want to show these in thousands, which will then show these in thousands. And then I want to remove it because I don't want the double numbers. So with the vertical axis selected, Control-1 to open up the task pane. Display units, thousands. And sure enough, that achieved our goal. But now I'm going to delete this. And there's our finished chart. And there, with the help of a little data modeling with the XLOOKUP function, we've created our two reports and our visualization. Now we're going to use these same two data sets and use slightly different tools. And to summarize here, we didn't have so much data. It was relatively quick and easy to add these XLOOKUP functions. And the calculations and the visualization we wanted are easily done with a standard pivot table and an Excel chart. Let's go over to the sheet Relationship, Data Model, and DAX Formulas. Now we'll go look at our Excel file that contains the three tables. Then we'll use Power Query in Excel and Power Pivot in Excel to create these data model reports. Now if you've never used Power Pivot before, you have to enable that feature. File, Options, Add-ins on the left, Manage dropdown, and we'll select COM Add-in. click Go, and then you check Microsoft Power Pivot for Excel. Or here's a great tip. In the Data tab in the Excel ribbon, Data Tools, if you click Manage Data Model, we're supposed to jump over to the data model. But when you click it and it hasn't been enabled, it says, do you want me to enable it? So I'm going to click Enable. And there we see the empty data model. And more importantly, there's a Power Pivot tab in the Excel ribbon. Now, the funny thing is, we don't really need to use this tab, but it does have to be showing so that this button works. And the reason we're not going to use the Power Pivot tab, when we click this to jump over to the data model, we can do everything we want, like creating relationships and DAX formulas more easily over in the data model. Now on the sheet PP, what does Power Pivot do? It creates data model pivot tables and does these things. It allows you to create relationships between related tables to avoid many lookup formulas like XLOOKUP. It allows you to use more than one table in a data model pivot table report. It allows you to import large amounts of data, which we do not have in this example. But in our last example, we'll have 7 million rows of data. So we can import, using Power Query, we import into a behind-the-scenes data model location called the Columnar database. This compresses the data and can hold millions of rows of data. And Power Pivot will allow us to create reusable formatable DAX formulas. These are formulas used in data model pivot tables. That means instead of using the default summarize values by and show values as, we'll build our own formulas. Now let's go over to RDM DAX. Now we can go look at our source file. In our video 4 folder, here's the example 8 source tables. I'm going to double click to look inside. Now on the table sheet, there's the fact table and 1, 2, 3 dimension tables. We used both of these tables in the last example, but we're also going to have a date table. And it functions the same way as looking up a unique list and returning a product name. From this date over here, where there are many duplicates, here we have a unique list of dates. And so we can find a particular day and return a particular attribute like month name, year name. You can actually add lots of other columns to a date table. Weekday, fiscal year, and many more. We'll actually do some of those other date attributes in later videos. But the only date attributes we're going to need in our reports are the month name and the year. Now you might be asking, why are we creating a date dimension table when a standard pivot table will automatically group dates into months and years? And the reason is, we're going to load all of these tables not to the pivot table cache, but to the data model. And when you're in the data model, because we can potentially have millions of rows of data, we don't use that automatic date feature in a standard pivot table. We build a date dimension table just like we would for product and sales rep. In addition, when we load these dimensional lookup tables to the data model, we're going to avoid having to create those helper columns where we use the XLOOKUP function. And the way we're going to do that is we'll create a relationship between each dimension table and the fact table. Now if we scroll up, I have a visual here that helps to understand relationships. Now in each one of these lookup or dimension tables, the first column is always going to have a unique list. That means one of each date, one of each product ID, and one of each sales rep ID. In a relationship, this is called the one side. However, when we go to the fact table, the sales rep ID column is allowed to have many duplicates. And that makes sense because this sales rep is going to make lots of sales. That's why this is called the many side. So what we'll do in the data model is create a one-to-many relationship. Then we won't have to add a helper column with a lookup formula. We can simply drag and drop fields from any one of the tables, and our report will work perfectly. So unique list, one side, over to the many. Unique list for product ID, over to the many. one-to-many relationships. So our next task is to import these 4 tables into our other Excel file. Now here's the thing. This is an Excel file, and we're going to import this using Power Query. Now remember the text files. When we import a text file, there is only one table in that file. But in an Excel file, you can have many tables, and you can actually have many types of objects, like defined names, or even the entire worksheet. So what we'll do is we'll say, hey, Power Query, I want to import the objects from an Excel file. And Power Query will immediately say, which one of the objects do you want? And we'll just check these 4 tables. So we'll close this, scroll down. We're going to create our reports down here. But first, we have to go up to Data, Get and Transform, and import tables from our Excel file. Get Data dropdown, from File, from Excel Workbook. We're going to click Video 4 folder. There's our Example 8 source tables. You can double click or select it and click Import. And Power Query is polite. It's looking in that file, and the objects that it found are 4 Excel tables and a worksheet called Tables. We want to select multiple items and check each one of our tables. By the way, that blue field name line at the top, that's the little icon that means this is an Excel table as opposed to a worksheet. Now, when we click Transform, it'll open up the Power Query editor and create an individual query for each table. So I click Transform Data. Here's the Power Query editor. On the left, we want to close the folder that has all the queries from combining the tables. There's our grade table. That's the first query we did. That's the many files into one. But here it is, DDate. We want to click on each query and make sure the data types are correct. Date, whole number, text, whole number. Those are all correct. That's a great name for our query, and those steps are fine. DProduct, we're checking data types. Whole number, text, the name is fine, the steps are fine. DSales, the data types are fine. That's a great name, the steps are good. FTransaction, date, whole number, text, and correctly it assigned decimal to the sales column, and then whole number for product ID. That is a good name. The steps are good. Actually, these 3 steps are the same in each one of these 4 table import queries. So if you go back to source in any one of those queries, open the formula bar, you could see the on-premise file path there. And notice the functions are named so smartly. Excel.workbook, because we're accessing a workbook. File.contents, because we're trying to get some of the contents from that workbook. And this formula delivers a table down here, if we scroll over, that has a column called Data, and in each row is one of the different objects. In fact, DDate, if you click off to the side from the word table, you can see a preview. That's the DDate table. Here, DProduct. So this column here has all the objects from the Excel file. That's step 1. It navigates through this table and selects just one of the objects. Up here you can see it got the F transactions. And there's the table. And those sets of applied steps are the same for each one of the import queries. Here navigation is getting DDate. Now, so we don't have to add any steps like we did in earlier queries. Now, all 4 of these have not been loaded. So when we go up to Home, Close, Close and Load dropdown, we definitely want Close and Load 2. In the Import Data dialog box, we definitely want to come down and say add this data to the data model. But when you use this in the future and you know you're going to the data model, your reflex has to be the very first thing you do is come down and check only create a connection. The #1 mistake people make when they're learning Power Pivot and data model is they keep this selected and then they come down and click this. And the problem is when you click OK, it loads the tables to the worksheet and the data model. So we want to say only create a connection by selecting this we're forcing this top part to have no effect. We're definitely not loading it to the worksheet, and we're definitely not loading it to the pivot table cache. So only create a connection. Add this to the data model. When I click OK, over here in Queries and Connections, you can see Power Query is working to import this. But also, the data model, that Columnar database, it compressed all of this data. Now you can hover, and we see loaded to the data model. That's to the data model, and this one too. Now that we've loaded these to the data model, we're definitely going to go look and build relationships and our own formulas. Now I'm going to use Control-S to save. Then I'm going to click the Manage Data Model button. Now you can see this opens the Power Pivot for Excel window. It's a new window on top of Excel. This is not Power Query. It's not Excel. This is our data model window. It has its own tabs. Down here, these are previews of what's in the Columnar database. They show it just like a real table. There's DDate, DProduct, DSalesRep, and FTransaction. Now what I mean by a preview here is if you have millions of rows in the Columnar database, it's definitely not going to load it all here, but it'll give you a preview. Now later we'll come back, and in the fact table, we'll build our formulas down in the what's called the measure grid. Now when we loaded this in the Home tab, View, we're in Data View. And you can see the little tabs. That means we're allowed to get a preview of the tables. But we want to go over to Diagram View. Notice the lines between the tables. This is where we can go and create relationships. So I'm going to click. Now what we see in Diagram View is the name of the table and a list of the fields. Now I'm going to arrange the fact table right in the middle, the date dimension table on the left, product, and sales rep on the right. And in Diagram View, there's two important things we can do. We create the relationships between fields simply by clicking and dragging. And then later, when we have fields in a table like sales rep ID that we don't want to show up over in the reporting area, that means the pivot table field list, we can hide them. Now let's first create the relationships. And here's how easy it is. I'm going to take sales rep ID and drag it over and on top of sales rep ID. When I let go, it creates that one-to-many relationship. There's exactly one sales rep ID in each row. And over here in this column, there can be many duplicates. We'll drag product ID from the dimension or lookup table over to the fact table. There's another one-to-many relationship. And from the DDate table, we'll drag the unique list of dates over to the many repeats in the transaction table. And there, by dragging and dropping, we have created relationships. And these relationships will help in two ways. The first way is it will replace all those XLOOKUP functions, which means the Excel file can calculate more efficiently or more quickly because it doesn't have all those formulas. And the second thing is we're going to be able to drag and drop fields from any one of these tables into our data model pivot table report. So in Diagram View, we create relationships. But we also want to hide fields like date ID. That's a field we're never going to use in our reports. And also a field like date, we want to hide that because we're going to use the date field over here. Also the number field, we're not going to drag and drop number fields into pivot tables. Instead, we're going to build our own formulas. So in FTransactions, we need to hide date. I click on that one, hold Control, click on Sales Rep, Sales, and Product ID. Right-click, Hide from Client Tool. What this does is it will hide these fields in the pivot table field list. Now, we kept region as unhidden in the fact table because that's an attribute or condition or criteria we can still drop into our pivot table, and we don't have a region dimension table. Product ID, right-click, Hide from Client Tool. Sales Rep ID, Hide from Client Tool. And month number. We don't need month number although we will use it later. The month category we're going to drop into our pivot table is this month. So we're going to right-click, hide from client tool. And by the way, any fields that are hidden, we're still allowed to use them. For example, we're going to use this sales field to create a formula in just a moment. When fields are hidden, they're just hidden from showing in the pivot table field list. All right, so we created relationships and hid our fields. Now let's go back over to Data View. Now in Data View, below the bottom of the fact table, we can create formulas in what is called the measure grid. If you don't see this measure grid, that's because area, calculation area, is not selected. I'm going to select this. Now I'm going to click in a cell below the table. And this is one place that you can create what's called a DAX measure. A DAX measure is a formula that you can drag into a data model pivot table. The other type of DAX formula that you can create in Power Pivot is a DAX calculated column. We're not going to create one in this example. Now, the DAX in DAX stands for Data Analysis Expressions. And expressions is a synonym for formula. DAX is a function-based formula language, which has some functions that are similar to the Excel worksheet and some that are unique to DAX. Now, when you're building DAX measures, there's actually two locations where you can build measures. Now, over in the Excel ribbon, there's a Power Pivot tab. And in the Calculations group, you can create a measure. I don't like how this feature here places the formulas in the measure grid, so I tend not to use this. Some people do, though. So I'm going to use the measure grid. And the formula is going to be similar to Excel, totally different than Power Query. And if you know Access formulas, it's exactly like Access formulas. So we need to name this DAX measure, and that name will show up in the F transaction table in the pivot table field list. So watch this. I'm going to start typing in the measure grid, and notice what happens. It jumps us up to the formula bar. Now that name will show up in the pivot table field list. But now we need to put an assignment operator and then the formula after it. Now, in the Excel worksheet and in Power BI Desktop, the assignment operator is the equal sign. Everything after the equal sign is the formula. But in Excel Power Pivot and Access databases, we have to type a colon and then an equal sign. Now, our goal here is to sum, so I can type sum. And we can see the sum function in the dropdown. Now, the sum function and other functions like average and min and max, those are the same over in Excel. There are other functions like summarize, SUMX, which are only in DAX. Now, I hit Tab, and it says that it wants a column name. Now, I can scroll down and then select. There it is right there. Or in Power Pivot, and this is different than Power BI Desktop, you can actually click on the column header. This is the same as Excel tables. So when I click at the top of the field name, it properly puts in the column reference. And column references always have the table name and then in square brackets the field name. Now I close parentheses, name of the DAX measure, assignment operator, formula. Now when I hit Enter, I get a result that gives me the grand overall total for every value in the sales column. Now you'll see the clever thing about DAX formulas is when we drop this formula into a data model pivot table, whatever the conditions and criteria are in the row column filter area, this DAX formula will see those conditions and criteria and give us the right answer. Now another amazing thing about DAX formulas is we can add number formatting to the formula. And then wherever we use this, that number formatting will follow us around. So home ribbon, formatting, I'm going to click comma, and then decrease the decimals. And there's our DAX measure. To show you two other simple DAX measures, we're going to calculate average sales up in the formula bar, colon equal AV. And the average function is the same as over in the worksheet. I'm going to select sales, close parentheses, and enter. Format this. So that average of $318, That's the average for every single transaction in the sales column. Another formula we might want to see count, or number of transactions. Hopefully I spell it right. Number transactions, colon, equal sign. And this is a unique function to DAX. This function does not exist over in the Excel worksheet or Power Query. Count rows. And it's asking for a table. So I'm going to put in F transactions. Notice I type FT. I see it in the dropdown, so I hit Tab. And the amazing thing is count rows will take that F transaction, and as it sees conditions and criteria in the pivot table, it'll count how many transactions there are that meet those conditions. Now we'll explain a little bit more about how that happens when we build our pivot table. But for now, close parentheses, enter, and this is going to be comma, and of course 0 decimals because we're counting. Now let's go back over to diagram view, and we can see the F transaction table has some new entries at the bottom. Now here we are in diagram view in the Power Pivot for Excel window, and this is a picture of our finished data model. Now there's 5 parts to this data model that we created. The first one we can't see. That's the behind the scenes Columnar database that compressed and stored the data. The second thing is we can get a preview of the tables either here in diagram view or over in data view. The third thing is we create relationships in this data model. Then we create DAX formulas. In this case, we created 1, 2, 3 DAX measures. Now the DAX measures over here in Power Pivot shows an f of x icon. This icon and the names will show up over in the pivot table field list. And then the last thing we created over here is we hid some fields. These are the fields we don't want to show up in the pivot table field list. All right, now we want to jump over to the Excel worksheet and make our first data model pivot table. I'm going to close the Power Pivot for Excel window with the X. Now on the sheet RDM DAX, we're going to select cell C37, go up to Insert, Tables Group, Pivot Table dropdown, and From Data Model. And now this dialog box says Pivot Table from Data Model. We just select the location and click OK. Now I'm going to go grab the Pivot Table Fields task pane, move it, resize it, expose all the tables. Now this is showing you all the tables in the data model plus all the other Excel tables that are in this workbook. If you hover, for example, it tells you that this has a range of cells source. But these, we know they're in the data model, but they came from a query. Now currently we're in the All tab, which means we could see every table from the data model and all the worksheets. Now if we go look at active, there's nothing here yet, meaning no tables or fields or measures, because we haven't added any to the active pivot table. But if you come back to all, and our first report is going to be a regional report. And since we want region in the rows, and that's the default, I can simply check. And instantly I get a unique list of regions in the row. And I see the field down here. Now we want to see total sales for each region. And I'm going to check this because the measured by default goes down to values. And look at that. We do not have to add number formatting. We'll check average, and it has our number formatting. But I would like to change the name of this and the formatting. So guess what? I can go back to the data model, Data tab, Data Tools, Manage Data Model. In Data View, I select the cell with the measure, come up to the formula bar. I'm going to call this Average Transactional Sales. Hopefully I spelled it right, and Enter. And I want to increase the decimal, so 1, 2. Now, we don't have to close this. We can actually leave this open. I can just take my cursor and click back in the pivot table. And look at that. That measure updated. If we had used this in many different pivot table reports, they all would update. And now let's do check mark for number of transactions. And there it is. For region, we have 3 different DAX formula calculations. If we go look in active, we can see all the fields we've used. Now let's come back over to all, and I want to create the next pivot table. So about 4 cells below, not Alt-NV-T for table in the worksheet. We'll use Alt-NV and D for data model. D. And because the OK button is selected, we can just hit Enter. Now this time I want a sales rep, but I'm going to right-click the table and force it right up front to go to the Active tab. Transactions also. Now I can come over to Active. And that is a thing of data model pivot table beauty. We're allowed to have multiple tables in the pivot table field list to avoid all those XLOOKUP functions. We definitely hid fields that we don't need. That makes this less cluttered. And we created reusable formulas called DAX measures that even have number formatting. So for our sales rep report, I simply check that to get my unique list, and then check, check, check. I have all 3 DAX measure calculations. I didn't have to manually number format any one of those columns. Now let's create our third report for product. And this time we're going to do the keyboard Alt-NV-D and Enter. We're going to send product over to active. F transactions over to active. Active tab, that is a thing of data model pivot table beauty. I'm going to check, 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 check. And there's our finished product report. Now I'm going to move this to the side. Select cell I37, Alt-NV-D, Enter. D date, right-click, show in active. F transaction, show in active. Come over here. We're going to drag year to rows, month down below years. And what is happening here? The months are sorted alphabetically. In a standard pivot table, there's a behind-the-scenes custom list that sorts the month when you drag it into a standard pivot table. But in a data model pivot table, that feature does not exist. To get our months to sort chronologically, we have to go back to Data, Data Tools, Manage Data Model. In Data View, we go to the Date table. We select the Month column. And remember, this has text, but month number, 1 to 12. If we could tell this field right here to always sort according to this field, then of course January would come first, February second, and so on. In all data models, when you have a date table like this, you have to use the Sort by Column feature. In Power Pivot, it's Home, Sort and Filter, Sort by Column button. You select the column to sort, month, and by month number. When I click OK, when we go back to the worksheet, the months are sorting chronologically. Now to finish our report, we check 3 measures. We need to change the column width. And I'm going to double click between any 2 to best fit the width of each column. And just like that, our monthly report is done. Now let's Control S to save. Now we got to talk about how these 1, 2, 3 reusable DAX formulas make their calculations in each row of each report. If we look at this second report right here, total sales, there's the formula. When we drop this measure down into the values area, behind the scenes, it calculated the correct amount for Ahmed, Chantel, Gigi, and it got the correct grand total at the bottom. And the way it did it is with something called filter context. And what filter context does is when this measure hits this row, it sees the condition Ahmed. That whole F transaction table is filtered down to just the records for Ahmed. And because the records are just for Ahmed, when sums that filtered sales column, it gets the correct amount. When it gets to the Chantel row, the entire fact table is filtered down to just the transactions for Chantel, and then the measure adds just the sales for Chantel. But when this same measure gets to the grand total row, there are no filters on the table, and so it adds to get the correct grand total. Now the whole filter context process is happening behind the scenes in the Power Pivot engine and Columnar database. So there's no way for us to go look and see how this is working. But guess what? The process is exactly like the filtering that we learned at the beginning of this video. Now I made a visual to help understand how filter context works on the sheet, filter context visual. But remember, when we created this report, we dragged sales rep from the sales rep table. Let's go look at filter context visual. Now here's a picture of the report we were just talking about. And here's the D sales rep table and F transactions, the fact table. And remember, from sales rep ID over to sales rep ID, there's a one-to-many relationship. And here's how filter context works. This measure right here, we drop it into the pivot table, but behind the scenes, as soon as the measure sees this cell, the context is the condition or criteria Ahmed. Because this is coming from the sales rep column in the sales rep table, it's just like we learned at the beginning of the video. The process filters to show just Ahmed. This single condition filter then flows across the relationship from the one side over to the many side. And sure enough, all we see is 5. Every sale is for just Ahmed. Once the filter has been transferred over to the fact table, that's when the measure kicks in and adds all the sales. Now, the reason that DAX formulas calculate this way is because if you have a lot of data, if we send the filter over here, the table is much smaller. Guess what? This measure only has to work across 7,694 rows instead of the full 43,222. So filter context makes sure that the formulas are only working over the necessary number of records to make its calculation. When the measure gets to the second cell here, Chantel, in the D sales rep table, now it's filtered to Chantel. The filter flows across the one-to-many relationship. All we see is 4s. All these sales belong to Chantel. And that's our result. And of course, when we remove all filters from the D sales rep table, there's no filter on the fact table. And there's the total. And for our count rows function right here, now you understand why the function is called count rows. All this formula does is look at how many rows are in the F transactions. When there's no filter, it sees 43,222. When we select GG, far fewer. Looks like 3,363 rows. So count rows counts how many rows. Sum adds all the sales. And the average formula, of course, averages these. So the moral of the story, filter context is amazing because it makes DAX measures work more efficiently. Now I want to go over to the sheet mistake. Now we want to look at 2 potential pitfalls when you build a data model. Now we were careful and built our data model to avoid these 2 pitfalls, but I want to show them to you. So let's go to Data tab, over to Data Tools, Manage Data Model. And in Diagram View, we very carefully hid the date field. That way nobody's going to drag it into a report. If you drag it into a report, something really bad happens to the fact table. Also, we hid the sales column because we didn't want anyone to touch that. We want them to use measures. But if you don't hide it and someone drags it into the pivot table, another potential bad thing happens. So I'm going to select Sales, hold Control, select Date, right-click, Unhide from Client Tools. Now let's go back to this sheet, and we're going to use our keyboard, Alt-NVD, and Enter. Over in the pivot table field list, I'm going to right-click F transaction, Show Inactive. Over here, we're going to mistakenly drag date in, and watch this. When I drag it down to rows, watch how long it takes. All right? I'm going to drag off everything but year. And now I'm going to drag the sales field. This is not a measure. Drag it over values. And already we're annoyed because it certainly didn't add any number formatting. But now let's go look at the data model. We want to go to Data View. And this is the fact table, and the product ID is supposed to be the last column. What happened here? When you drag a date field into a pivot table, it thinks you want to group the dates. The problem is this is 43,000 rows for each one of these columns. That's too many formulas. When you use a date table and a relationship, we only have 2 years, so this is only 720 rows. Back over here, the other thing is when we drag that sales, a number field into the pivot table, Power Pivot actually created a DAX measure, but it's hidden. If we go to Advanced, and I don't know why they don't have this on by default, we're going to click Show Implicit Measure. And sure enough, this is called an implicit measure. This is the one automatically created by the pivot table. This is called an explicit measure. We created it ourselves. Now, there are many problems with implicit measures. The first is, well, it's hidden. Second is, this is a read-only formula. You can't edit the formula. You can't add number formatting. Notice this is grayed out. You can't change the name. You can't reuse it from the pivot table field list. And when we export our data model to other tools like Power BI Desktop, implicit measures do not show up. So our rule is we don't use implicit measures. We always want to use explicit measures, which just means we create them ourselves. Now, the best thing about implicit measures is we unhide them and then right-click Delete. Yes, I'm going to delete from Model. I'm also going to select Date, hold Shift, click on Date Month, and right-click Delete Columns. Yes. Go to Home, over to View, Diagram View, select Date and Sales, and right-click Hide from Client Tool. Now, there's another way to prevent the date field from creating all of those extra columns attached to the fact table. If you go over to DDate, and this works in Power Pivot and in Power BI Desktop, we want to go to the Design tab. And we're going to tell Power Pivot that this is a date table. As soon as we do that, it will no longer add those extra columns to the fact table. So Design, Calendars, Mark as Date Table. So I click and click Mark as Date Table. It wants to know where the unique identifier is. That's our unique list of dates. So that's correct. Click OK. And now no matter what we do, we're not going to get all those extra columns with 43,000 formulas in each. All right, let's go back to RDM DAX. All right, we saw some great advantages with a data model pivot table using Power Pivot. By having multiple tables, we were allowed to create a relationship and avoid all those XLOOKUPs. With multiple tables, we can drag and drop from any field into a pivot table. We have reusable, formatable DAX measures. We also hid a lot of unnecessary fields. We saw that filter context helps the formulas calculate more efficiently. And guess what? If we have a data model inside an Excel file built by Power Pivot, we can automatically send it over to Power BI Desktop, where we have lots of interactive visualizations that are actually a lot nicer than what we have in Excel. So that's our next task. Now you want to make sure and save this Excel file with a data model. And before we go over to Power BI Desktop, which is a different program, in this Excel file, let's go to the sheet BI Desktop. Now Power BI Desktop does these things. First, it's a free Microsoft download. You just click this link and download Power BI Desktop to your computer. And when you get it open and start working, Power BI Desktop has the same tools as Power Pivot and Power Query. In fact, all the tools in Power Pivot and Power Query started in Excel first. And then they invented this other tool called Power BI Desktop, which is designed to have better visuals and shareability. Now, Power BI has more varied visuals and reporting tools than in Excel. And the visuals are interactive. There are also more DAX functions, including table functions. And once you create a data model in Excel Power Pivot, you can import your Power Pivot data model into Power BI Desktop. Now, Power BI Desktop is the free download. That's where we build the data model and all the visualizations. Once you have that file complete, you can share that file the traditional way by emailing it to someone. And a lot of people in the world do it that way. But there's a second tool called Power BI Online. And Power BI Online requires buying a license. Now, this is August 18th, 2022. And by this time in history, many entities buy Power BI Online for employees when they buy Microsoft 365 Office. And here's what the online version does different than Power BI Desktop. You can upload your Power BI Desktop file to Power BI Online, and then it's easy to share the reports, visuals, dashboards, and the data models. Also, you can upload Excel files and the Power Pivot data models inside of Excel files. Now, the sharing of reports and visuals, that's on the information side. That's when you want to share your results with people. But there's a whole other side to Power BI Online. When we upload data models from Power BI Desktop or from Excel Power Pivot, they become universally available to assigned groups of workers. Or here at Highline College, an assigned group of students and teachers. That means when you upload data models, groups of workers can access the data from within Excel or even Power BI Desktop. This means there's one source of truth, one location for the data. No need to share files by email. And let me just show you, we already saw an example of this. If you go up to Insert Tables, drop down for Pivot Table, there it is. Once you upload your data model, all your fellow workers have access to it. No more emailing your file with the tables or the data model. You just upload it here, and then everyone in their different office, or here at Highline, different classrooms, they just go to Excel, log in, and they can access the single source of truth data set. Now, in Power BI Online, the way you share things is you create online workspaces for groups of workers to share reports, visuals, dashboards, and data models. And all it involves is just adding the emails for your fellow workers or fellow classmates. And then you can share your data models, visuals, reports, and dashboards. Now, we'll come back to this Excel file a little bit later and upload the data model, and then we'll see how amazing it is to have this universal place to save data. But what we're going to do next is we're going to take our Power Pivot data model from this Excel file and import it into a new Power BI Desktop file. And then we'll look around and get introduced to Power BI Desktop. However, before we do that, please Control S to save this Excel file, and then close this Excel file before we go over to Power BI Desktop. Now, I've already downloaded Power BI Desktop. I have an icon to open it on my taskbar, and I can see the folder path with this file. That's the file that contains the data model. So I open a brand new Power BI Desktop file. Now, here's the Power BI Desktop file. It doesn't have a name, and it hasn't been saved. So we use the same keyboard as Excel to open Save As, F12. In the Save As dialog box, we're going to navigate to our class folder. And we're going to call it, this is what I'm going to name it. You can name it that also. And then click Save. There's our name in the title bar. Now, before we take a tour of Power BI Desktop, I want to import that Power Pivot data model. To do that, we go to File, Import, and this option, Power Query, Power Pivot, and Power View. We're going to click. In the Open dialog box, we navigate to our class folder, and there's our file that contains the Power Pivot data model. Let's click Open. This message says, hey, I cannot import everything from an Excel file. I can only import queries and what's in the data model. Now, when we click Start right here, we're going to get all the queries from that workbook. There are a few we don't need, but we'll easily delete them. Let's click Start. And the migration is complete. Here's all the queries. Here's the data model items. Let's click Close. Now we could take a proper tour of Power BI Desktop. This is the Power BI Desktop ribbon. It has tabs. And over here, 1, 2, 3. Those are the 3 areas we can work in Power BI Desktop. If you hover, This model is like diagram view in Power Pivot. Let's click. Oh, and there's our imported data model. It got everything. I think if we look around here, adjust things, the table, the fields, the measures, the relationships, and there's a few differences over here. Look at that icon for a measure. It's like a little calculator instead of that F of X in Power Pivot. And instead of a hidden field being grayed out, there's an eyeball with a line through it. So this for us in Power BI Desktop is called Model. Over in Power Pivot, Diagram View. Now if we hover here, this is data. This is like data view in Power Pivot. So when I click, I can see the tables. Over here, there's a list of tables. I can click to expand, and I see the fields and measures. I can click on F transaction, and there's the table. I also see the measures. So data is like data view over in Power Pivot. And here, this is report. When I click, this is like the worksheet. The worksheet would hold data model pivot tables and Excel charts. And for that matter, you can put anything else from Excel in the worksheet. Here in report view, over on the right, here are visualizations we can choose from. We can open tables and drag and drop fields and measures into our visualizations. There's a filter area also. Some of the possible visualizations and reports, well, there's a bar. There's the other type of bar, clustered, stack column, clustered column. There's a line chart, XY scatter. There's a cool map. There's a table, a slicer. And this is similar to a pivot table, a matrix. There's also a bunch of other different visualizations. And Get More Visuals is awesome. You can go and download all sorts of amazing visuals. So we have report, data, and model. But where is Power Query? Well, Home tab. Everything in data and queries, that's Power Query. In Excel, we have the Queries and Connections pane to open queries. Here in Power BI Desktop, Queries, Transform Data dropdown. Transform Data. Notice it says this opens the Power Query editor. Also, notice this is Data Source Settings. That same setting in Excel is Data, Get Data, and all the way down to Data Source Settings. Let's go look at Power Query Editor. It looks almost the same as over in Excel. If we select the query F transactions, there's the preview, name and applied steps. Now, we don't need a bunch of these queries. We're going to collapse this folder. Before we can delete it, though, we have to delete the query many files from one table because it is using elements from in that folder. Click, hold Shift, click on Summer Business 101 Scores, right-click Delete. Yes, I want to delete the queries. Right-click the folder, delete group, delete. Now over here in Power BI Desktop, it does not say close and load to. Over in Excel, we get to choose where to load it. Here in Power BI Desktop, we can only load it to the Columnar database in the data model. So close means to close the window. Apply means to apply the steps and load it to the Columnar database. There's the dropdown, but for us, we just click the button, Close and Apply. And the steps are applied. Next, we want to build our visualizations and reports. We want to create this sales report page that shows region product sales in a crosstab report. It also visualizes the sales for sales rep using a column chart. And then using a line chart, we want to see the trends over the last 2 years. But the thing that distinguishes Power BI is if I want to analyze the trends for Chantel and see the crosstab with just Chantel's sales, I simply click. And that is amazing. There's the trends for Chantel. And the whole table, region and product, those are all Chantel's number. That's about 3.9 million. Sure enough, that's the column height. And if I want to remove the filter, I simply click again. I come over and I'm interested in Spitfire. When I select Spitfire, this is highlighting just Spitfire sales for each sales rep. And here's the trend. Click it again, and the filter goes away. Now, the first visual we'll create is a line chart. I'm going to click somewhere in the white area, go over to Visualizations, and there's the line chart. Click. We can resize it, make it a little bit taller. And moving over here has a different cursor, and sometimes it's actually kind of hard, but it's that white cursor. Look at that red line. It means I'm right in the middle. I'm going to let go. In Visualizations, when we're in Build Visual, we can drag and drop fields and measures to these areas of the chart. So we'll have year in the X, month below year, and then total sales is going to go in the Y-axis. Now, before we format and do a few other things, let's talk about this awesome area here. These three dots give us more options. If we click, we can actually export the data from this particular visual as a CSV file. Show as a table. If we click that, there's a table down here. We have a Back to Report button. We can remove and spotlight. Spotlight doesn't work here because we don't have any other visuals, but it would highlight this and gray everything else out. And then we can uncheck Spotlight. We have Focus Mode, which expands the particular selected visual. We can click Back to Report. We have a Filter button that'll tell you how it's filtered if you have filters. We don't have any. And then we have 1, 2, go to the next level buttons, and 1, 2, drill buttons. Now, we're already drilled up to the highest level. If I select drill down, this just turns it on. So when we click a particular data point, it shows at the next level all of those data points that make up 2021. So when I click, there's January to December for 2021. Drill up, I'm going to turn this off. Now go down the next level. If I click this for a year month, this may or may not be an appropriate chart because that's all the Januaries, all the Februaries, and so on. Drill up. This is probably the appropriate one. It'll go down a level and show year and month. Now, we have the year repeated many times. I think I'd like to see just one. These labels have been concatenated. Over in Format, that's our little paintbrush. There's different areas. And if you're coming from Excel, it does take a while to get used to where everything is. We want to do something to the X-axis. If this was collapsed, you can open up Values. And sure enough, down here, Concatenate Labels. We're going to turn that off. We can collapse this. It would be nice to have data labels. So down here, data labels. We'll say on. Now let's go back over to Build Visual. And here's something that does exist over in Excel in a pivot table. If you hover over a point, it shows you a tooltip. But over here in Power BI Desktop, we can do better than just showing the amount that's in the vertical axis. Build Visual down here is Tooltips. We can drag other measures. Here's number of transactions. And when we hover, both are listed in the tooltip. We drag Average. Down below, number of transactions. And that is beautiful. Every one of these tooltips shows 3 measures. And they're calculating the measures based on the conditions and criteria at this point. So this would be 2021 March. Now, when we created the tooltip, that title is too long, and we don't really need it because we have total sales over here. So let's go over to Format, and there's a Visual and General. Here's the title. We'll select Off. All right, so we have our line chart. Next, we want a matrix, and I got to show you a gotcha. I do this all the time. I want a matrix right here, but I accidentally leave the line chart selected. So when I come over to Build Visual, I'm thinking I'm going to get a new matrix, but when I click it, it's polite. It thought I wanted to convert that line chart to a matrix. Luckily, Control-Z gets us back to our line chart. The trick is when you create a new visual, make sure that the white area is selected. And now let's do a matrix. We can resize it, something like that. And when we move it around, we can see those lovely red lines. And in Build Visual, it looks sort of like a pivot table task pane, rows, columns, values. So we'll take region from F transactions. That's going to be in the row. There's our unique list. Product, we'll put that in the column. There's the unique list. And we'll drag total sales down to values. And there's our cross-tab report showing region and product. Now let's click in the white and create a clustered column. We want sales rep. We can check this and it will go to the horizontal axis, our X, and then total sales to the Y. Let's add tooltips here also, so number of transactions and average. We don't need this long title. So over in Format, General, we'll turn the title off. Back over to in Format, Visual, let's have data labels. And now when we hover, we can see our three measures. And here's one of the things that makes Power BI Desktop so beautiful. When I click, the line chart is filtered, and so is the cross-tab report. Now we click Chantel to unfilter. Now we're allowed to control how these visuals interact. We go up to Format, then click Edit Interactions. So we have the column chart selected, so I'm allowed to, on the other two visuals, decide whether I want it to filter or no. I do want it to filter. Same here, I want it to filter. Selecting the line chart, we get to decide filter or not. But over here, we get a third option, highlight, and that's the one we want. That means when I select an item over here, like Spitfire, it highlights just the amount, leaving the total there for easy comparison. And then this one, of course, is filtered. Clicking Spitfire to turn it off, we can uncheck Edit Interactions. Over on the right, we have the filter pane. And this filter does three things. It can filter on the selected visual. It can filter the entire page, meaning all the visuals or reports. And you can have filters on all the pages. So if you have new pages or tabs with other visuals and report, a filter here filters them all. If we select the line chart, here's year for the selected visual. We can open it up. We could select the logical test equal to, which is, and then type, I want to see just 2021. And then you have to click the Apply Filter button. And bam, just this visual is filtered for 2021. To clear the filter, you can use the eraser. Now we would like to do a few more things to this report. We want to add a title, a slicer, and a card showing total sales. I'm going to move this a little bit to the left. Let's move this down. We'll move this down. All right, over here, let's click in the white, and we're going to start with a slicer. And we want year. Then from the drop down, we can say list. Resize it. Now click in the white, and we're going to have a card. And we're going to drop the total sales measure. We can resize it, move it up a little bit. And up in Format, call out value, and we'll say value decimal 1. Click in the white. We'll try a text box. And we can write Colorado Boomerangs. That's the name of the company. Sales report. Control A. Let's say 28. Bold. We can resize it. There we go. And center. Click off to the side. Now we can select 2020. It filters everything on this sheet. 2021. And erase. So the sales report is looking good. But we want to create another page and show some different metrics for the region. So we're going to add a new page. Double click and call it Region Report. All right, we click in the white. Come over to our visualizations. We want a matrix. And we're going to put 3 variables in the row. We'll start with the region field from F transactions. And then year, we're dragging it down. If we check these, they tend to go to columns, so I'm dragging. And month below year. Now, if you don't see these expand buttons, you can come over to Format, Row Headers, and turn it on or off. Back over to Build. We want total sales. Down in values. Actually, we can check these and number of transactions. We'll expand this. Let's increase the font size for the whole matrix. Over to Format, Grid. Again, sometimes these things are hard to find. You wouldn't think it's grid options, but sure enough, global font size. And I'm going to increase it to 12. Resize it. Bring it all the way down to the bottom. Actually, we're going to have a title at the top, so maybe right about there. Right-click, expand to next level. So that's how we'll leave it. And then as we're analyzing over here, we can open the years. Now let's click in the white, and we want 2 regional bar charts. One for product, one for sales rep. Now we're going to look at the difference between stacked and clustered. We're going to look at bar charts, but the difference is the same for stacked column and clustered column. Let's start with stacked bar. Bars are always horizontal. Now we want region in the y-axis, and then product in the legend, and then we'll check total sales. There's a stacked bar. And it's called stacked because the items in the legend are stacked one on top of the other. Now you use a stacked bar chart like this when you want to directly compare the variable in the axis using the lengths of the bars. It's very easy to see which one of these regions is the biggest and the smallest. So the emphasis is on the variable in the axis rather than the variable in the legend. But if we switch to clustered bar, now it's very difficult to compare the totals for the variable in the axis. But it's very easy to compare the differences across the product or the item in the legend using the column heights. And it holds exactly true. If we switch over to stacked column, it's this variable down here that's being emphasized by easily comparing column heights. If we switch over to clustered column, the emphasis is on the items in the legend, so we can compare within each region the items from the legend. Now let's go back to stacked bar. Now if you want to change the colors of the columns, you come over to Format, down to Bars, and there you can change all the colors. I'm going to leave these colors just as they are. Pull this up. By the way, I like the title. I like everything. This came out virtually perfect. Let's add some data labels. A data label, so over to Format, down to Data Labels, and on. Now watch this. Here's a great trick. I need the same exact chart, but all I'm going to do is change the item in the legend. Make it a little bit less tall. Control-C, click in the white, Control-V. There we go. And with this selected, we'll remove the legend, and watch what happens. There's actually no difference between stacked and clustered when there's only one variable. But we want to go up to our sales rep table and check sales rep. And now we have 2 beautiful charts, region sales rep, region product. And here's how amazing this whole setup is. If I want to look at just Northwest, there's all the sales reps and the products, and it shows me the detail over here. I can expand to see a particular year. Click it again. We can click on the outside edge also to unfilter. Now if we're going to use this as a filter and we only have one bar, instead of highlighting, let's edit the interactions and filter this. I think it'll look better. Format, Edit Interactions. We have this visual selected, so I'm going to come down here and say Filter, and select this one, and change this to Filter. Now we can turn it off. And now when we click Northwest, that's looking better. Click off to the side, remove the filter. And if we select Sioux for West, that is looking good. And the cool thing is, if you add up all those amounts, it's exactly equal to 0.62 million, or the total down here. Now I'd like to see an Excel chart do this. This is why if we have a data model over in Excel Power Pivot, might as well send it over to Power BI Desktop and take advantage of some of the interactive visuals. Next, we want to add a title to our report. Text box. I'm going to click on the outside edge, down to Effects, and Background Color. I'm going to add a very light gray. Because the next thing we want to do is I want to insert the Colorado Boomerangs logo. Insert. Over to Elements Image. And in our Chapter 4 folder, there it is, Colorado Boomerangs. Double click. We can resize it. And that is looking good. Now, there's one last thing I'd like to do. Actually, I want to show you something about formatting. Now, I am going to change the colors here. I'm going to go over to Format, down to Bars. And I'm going to change this to a medley of blues. So I'm using all these related blues. And that's looking pretty good. Now, I do all my formatting manually. But in Power BI Desktop, Excel, Word, PowerPoint, all the Microsoft tools, you can go up to View, and I have no idea why this is not in Format. And there are themes. Now, themes will add formatting to everything. You can look through these. Also, you can browse for themes online. But if I select this title, it formats everything for me. Now, again, I don't use themes, but you might like to. Now I'm going to Control-Z, and there's our finished regional sales report. Now our next task is to publish this Power BI desktop file. And we have 2 pages with 2 reports. And the file itself will show up at Power BI Online listed as a report. We want to also publish our Excel workbook file. And when we publish this, it'll be listed over at Power BI Online as a workbook. But before we publish either one of these files, you have to have a Power BI Pro license or higher, and you have to be at an organization that assigns emails to everyone in the organization, like a business or here at Highline College. And the way you log into Power BI Online is you have to use your institutional email. So here at Highline, the students in Business 218 class and teachers and administrators, they'd have to use their Highline issued email to not only log into Power BI Online, but also into Power BI Desktop and, of course, your Excel file. Now, the dialog box for logging into either one of the files or Power BI Online is exactly the same. So we're going to jump over and look at Power BI Online first before we upload these files. Now, there's lots of ways to get to Power BI Online. One of them is to use this address. You could also get to it from your Power BI desktop file, your Excel file, or even Outlook. Now, I'm going to type powerbi.com and enter. It wants your email, and it reminds you here about organizational email. So I have to enter my Highline College email and enter. And this is the page that all apps and the website will make you go through. You have to go through your institution's login system. I'm lucky I have an easy password. It's just a bunch of dots. But when I hit enter, it opens Power BI Online. Now here's the home page, and it may have some recently used reports or workbooks or workspaces here. There's also some items here. But what we really want to do is to go over to Workspaces. And each one of these workspaces is a location that has designated emails so certain people can access each one of these workspaces. Now I'm going to first show you how to create a workspace, which is just a few clicks. I'm going to call it Fall 2022 Business 218. Now I added a description and uploaded a picture. Now I click Save. Now we have no content in our workspace yet. To add emails, we come over to Access. And you enter email addresses. Now I added one person from our entity, Linda Quick. Also, we get to decide what type of participant. If you want to learn more, you can click this. And there's a detailed list. We're going to add contributors, which allows us to do all the things we want to do, create, edit, and upload reports and workbooks. So we change this to contributor. Click Add. We have 2 people in the workspace. We could add lots more. And actually, for this class, I will add all the students in Fall Business 218. Now let's add some content. That means we'll go back over to those 2 files. Now you do have to sign in to both files, but once that's done, we save our file. We have our 2 pages, and then in Home, we have the Publish button. Click. And of course, it wants to know where is the destination. There's our destination. Click Select. It's publishing. And if you don't have Power BI Online open, they provide a link. You can click this to jump over. Now it opens in Power BI Online and shows you the report you just published. But over here on the left, we can click on our new workspace. There's the report, that's the Power BI file, and the data model that was in that Power BI file is called a data set. Content, that'll show you your reports and workbooks. Data sets and data flows, that'll show you your data models. Now we can also click to open up our workspace. We don't have any dashboards later, but that's a place where we can pin things from reports. There's our report. We don't have a workbook. And there's our data model. Now let's go look at our report here in Power BI Online. Now it works the same as over in Power BI Desktop. We can click to filter and click to unfilter. Over on the left, we see our pages. I select region. I want to see quad in the east, filters perfectly, and then unfilter. Now anyone with access to the workspace can view the report. But there's some other options. Up here, you can save a copy. That actually saves it online. Download this file. This will download a Power BI desktop file. You can print the page. You can even, if you have a website, embed code. Click this, and you get the code. There's also a generate QR code. Over here for export, we're not going to use this one because we'll open it up from inside of Excel, but you could export it to PowerPoint or PDF. You can also share this report. You can copy the link and email it to someone. Directly email from here, even Teams and PowerPoint. Now we want to go back over to our Excel file. Now here we are in our Excel file. And when we publish this to Power BI Online, the worksheet data will show up as a workbook. None of the queries will show up. And the data model will show up as a data set that we can use in various ways. Now, in our second Power Query example, I actually added some formatting and a title at the top just to tidy this up. Because in Power BI Online, we're actually going to pin this report to an online dashboard. Now save this, and here's how we publish. We go up to File, Publish, and there's two options. Upload your workbook. This allows you to interact with your Excel workbook, but not in Excel. It is in Excel Online, which is a very limited version of Excel. And then, of course, you can pin selections from the workbook and share. This is the one I usually do. This will just upload what's in the data model. But I am going to show you this one. So before we click either one of these, you have to choose a workspace. And there it is at the bottom, Fall 2022, Business 218. Now we're going to click Upload. Down at the bottom, you can see it's working. Up at the top, it gives us a yellow banner, and we can jump over to Power BI Online. So I click. I got this message, but I'm going to click OK. Then we're going to go look at our workspace, open the drop down, and I don't know what that message was saying. There's our workbook. Now when we click on the workbook, again, it's only going to show us just the worksheets, not the queries, and it opens in Excel Online. This feature is just for us to view stuff. You can see all the tabs below. That was built with a query, but the query is not here. But the result is, let's go back over to PQ2PT. If we look at data sets, now we have two, and we uploaded Power Pivot data model to our Power BI desktop file. So these two are the same. And later in Excel, we'll see that now we have access to these. So we can use this as our one source of truth and build pivot tables over in Excel. Now, before we do that, we want to look at one last thing over here in Power BI Online, dashboards. That's just a location where you can pin anything you want from any of the reports or workbooks you have. Now, the word dashboard is very common. It just means one location where we can present useful information and metrics for making decisions. But dashboards are not limited to Power BI Online. You can absolutely make a dashboard in Excel. And in fact, this page that we made in this Power BI desktop report, this can be called a dashboard also. But when we're in Power BI Online, Dashboards are a specific location where we can pin important information and then share those dashboards easily. So in summary, a dashboard is one location where you can present useful information and metrics for making decisions. Information is presented in a neat and organized manner. Dashboards can contain tables, charts, visualizations, data validation, pictures, and other visualizations of data. And when new data arrives, the dashboard can be refreshed. Just like a dashboard in a car, a dashboard should present information that is required to make good decisions. Now to see how Power BI Online dashboards work, let's go to this report. I want to pin this to a dashboard, and we don't have any dashboards, but it will ask us to create one. So we go up to the top, More Options. We want to pin this to a dashboard. We don't have any dashboard, so it's polite. It wants us to create a new one. I'll call it Colorado Reports and Pin. Now, you can also create a mobile layout, and we're not going to do that, but you click on that and drag, and that determines how it will look on mobile devices. There will also be this web view also. And there's a dashboard. So we can click, and sure enough, this has been pinned to this dashboard. It works just like if we were looking at the actual report. I'm going to go back to our workspace. We'll go back to the report, regional report. We'll go ahead and pin this one also, pin to dashboard. There's our dashboard, pin live. Now I'm also going to pin something from an Excel workbook, although the way it works is clunky. So I don't usually do this, but you never know when you have something in an Excel workbook that you want to share. I'm going to highlight. And this one's way over here. We see pin, and it will pin this selected range. We're going to put it right in the Colorado Reports dashboard and pin. Now we can go look at our dashboard. So this is working here. We have this one. It's working also. And down here, we have a picture of our report and chart we created over in Excel. Now, if you click this, it jumps over to the Excel workbook. So that part of it seems clunky to me. We're going to go back over to our dashboard, scroll down, and the little options here, I'm going to say delete tile. Now, the advantage of the dashboard is that, of course, you can take various things from various reports and workbooks, and then you have some options up here. You can save a copy. That saves a copy of the dashboard. Print it. You can share it. I'm going to uncheck Allow Recipients to Build Content with us. Send an email notification. And up here, I'm going to put an address. And then grant access. Now I'm on my cell phone and I'm looking at my email. There's the invite. I'm going to click it. Open this dashboard. Now when you click Open this dashboard, if this is the first time you're viewing on your phone, it'll ask you to download the app and then log in using your organizational email. And sure enough, I click the dashboard, and there it is. And I can't really give you a good view, but it is interactive. I opened this one report, and on the phone, it is interactive, just as if we were in Power BI Desktop or the web version of Power BI Online. So I'm filtering and then unfiltering. That is why Power BI Online is so wonderful for sharing. Now, one last thing. I use Outlook Online all the time, and up in the left-hand corner, there's an app tile. You can go to Online Excel, but this is how I usually get to Power BI Online. All right, so that was a lot of fun with Power BI Online and Power BI Desktop. Now that we have two data models stored at Power BI Online, next we want to see how to connect to our online data models in Excel and Power BI Desktop. I've opened a new Excel file, saved it with this name to our folder. I named the sheet, and I'm logged in. And you are not going to believe how cool this is. I get to go to Insert Tables, Pivot Table dropdown, and there it is. Or I can use the keyboard. Remember Alt and V, that opens the dropdown, and there it is. B is for Power BI Online. So tap B. And look at this. It opens up a task pane called Power BI Datasets. Now, I'm the administrator and have all sorts of different workspaces over there, so I have access to all sorts of data sets. But if you didn't see the data set right at the top, you simply type 04-M365 and enter. And there it is right at the top. This one is from our Power BI desktop file, and this one's from the Excel file. I'm going to use the Excel data model and click Insert Pivot Table. And here's our Pivot Table field list. And this is the data model that we're connected to online. These tables were not imported. This is only a connection to that one source of truth sitting online at Power BI Online. If you go look in the data model, there's nothing there. And this is nice. We have the measures at the top, the 3-dimension tables, and that one lone field from the fact table is listed down here. Now I'm going to select year, region, sales rep. Year went to column, so I'm going to drag it above rows. And then check, check, check. And there I have created a data model pivot table with that lovely number formatting automatically coming from the DAX formulas. One other note, these were explicit measures. That means we authored these measures. As we mentioned earlier, if you create implicit measures, either in the Excel file or the Power BI desktop file, those measures will not show up when you connect to this live data model data set from Power BI Online. Now I'm going to Control S, and we're going to jump over to a new Power BI desktop file. I opened a new file, saved it with this name, and the data source here, we go to Get Data, and there it is, Power BI Datasets. And notice it says Create a live connection to datasets in Power BI Service. So I click. I see the one I want right at the top, so I'm going to double click. And over here in Report View, we see all of our tables, including F transactions with one field and 3 measures. Now I'm going to hit pause and create a new page. You can create any page you want. And then I created this dashboard. Click and it's all filtered. Click again, unfiltered. And if we go to model, it shows us a picture of the model, but that data model is not really here. Oh, we have model and report. Well, there is no data tab because the data isn't here. It is still stored in the Power BI Online website. So that's a pretty cool use for Power BI Online. Store a data model online and access it from anywhere. Now we're back in our original Excel file. We're on the sheet Refresh 8 and 9. And this is a map of our data connections, for example, 8 and 9. Here's the file. This file has the source data, the Excel tables that we then imported into this file. Then we built a data model, and from Power BI Desktop, imported it into this file. Then when we published both of these files to Power BI Online, those data models were stored online. And then we connected both of these files to the data models online. That means if we go add some data to this file and refresh all the way through, everything will update. So we're going to go open this file. Here's our file. We have 1, 2, 3, 4 source tables. And we have 2 things to do. We're going to add new transactions for a new year to the fact table. And then we're going to update the date table. Click in a cell, Control down arrow, scroll down. I put new transactions here. Click in a single cell. Do not include the field names. Control asterisk. Control C, and below the table we Control V. Instantly those records are incorporated into this table object. Control Home. Now the date table has to have a unique list in this first column of every single possible date from the fact table. Well, right now if I Control down arrow, this table only goes to the end of 2021. Now I'm going to show you a killer trick here when you have your date table in the Excel worksheet. Now these are actual dates, but look up in the formula bar, month, text, and year. These are all formulas. This is an Excel table. So if I can just quickly add the whole new year of dates, everything will automatically be copied down. Now, here's a great trick. You select the last cell with the last date. There's the fill handle. Hover your cursor. And when you see your crosshair cursor, you're not going to click. You're going to right click. So here we go. Right click. Drag one cell down, back. And when you let go, you get a secret drop down. Let go. And there it is, down at the bottom, series. Now, there's other ways to get series, but this is the fastest. I'm going to click. And whatever you do, don't leave it rows, because that'll shoot the dates to the right. We want to shoot them down the columns. Step value is 1 day at a time. And all we have to do is put the end date, 12/31/2022. And when I click OK, that is a thing of beauty. That's using a series trick, formulas, and an Excel table. And that's it. Now we have to save this, Control S. 2 of our tables have been updated. I'm going to close this file. Now in our Excel file, we go over to the worksheet RDM DAX. The data was imported by Power Query. All of this is coming from the data model, so all we have to do is right-click, refresh. And there we go. There's the complete new year, and all the amounts have updated. In our Power BI desktop file, we go up to Home, Queries, and click Refresh. It's refreshing. And there's the new totals. Now I had to adjust the font size, but that is looking good. Let's go over to Sales Report. Wow, look at the trend. And for some reason, the summertime, June and July, wasn't nothing, but now that is a huge jump. Control S. And now we click Publish to send the new version to Power BI Online. Select our workspace. Select. It's polite. It's asking if we want to replace him. We do. We need to republish our Excel file. File, Publish. Be sure and select the workspace and upload. I definitely want to replace. And then the beautiful thing is, over in Power BI Online, when I go look at our dashboard, look at that. It is updated. So is this. Now, when we open up our Power BI desktop file that was connected live to Power BI Online, it's already updated. In our Excel file that's connecting to Power BI Online, we have to right-click, refresh. And there's our new data. Control S. Control S. All right, so example 8 and 9, we learned all sorts of things. How to use Power Query to import data, how to build a data model, import a data model from Excel into Power BI Desktop, upload to Power BI Online, and even connect to Power BI Online data sets. Now, our next example, we're going to use Power BI Desktop, but we're going to connect to an online database with 7 million rows. Let's go over to the sheet PBID 10. In this example, we're going to use Power BI Desktop and Power Query to import 7 million rows of sales data. That's a lot of data. Now, for some of you in this class, you're like, we never get that much data. Well, you do get that much data. For big companies, 7 million rows is not even big. And then we're going to build an interactive gross profit dashboard. Now, we're going to go over to this next sheet and talk about what we're going to find when we import the data from a structured query language, that's SQL Database. We're going to have a fact table with date, product, the website where the product was sold, the country code where the product was sold, how many units were sold for the transaction, what the revenue discount was. So for this transaction right here, for every $1, the customer got 35.3 pennies off for every $1. And then there's net standard cost. In this case, for every $1 of cost from the lookup table, the charge is 1.03, so $1.03. That means the price was increased by 3%. Here, the price was the same. Down here, 0.99, that means there was a 1% discount. Now, it's important to understand how these columns are working because we're going to have to calculate revenue, a synonym for sales, and cost for each transaction. The next table, dimension table, there's what's called the primary key country code. That will be hooked up with this foreign key. This is the one-to-many side. And then this is the product table with retail price, standard cost, and the category for the product. Primary key, foreign key. This is the many side. This is the one side. We'll have to look up and use both the price, that's for selling it to the customer, and the cost. That's for the business on the expense side, the cost side, how they calculate expenses. Now, this table is 22 rows. This is 126, but this is 7.7 million rows. Now, let's go talk about the Columnar database. Because when you have 7 million rows, that Columnar database makes the impossible, because you could never have 7 million rows in an Excel worksheet. It makes the impossible possible. Now, just as a small example, this table right here has 606 rows. It has 4 columns. That means the total number of cells or bits of data is 2,424. But what a columnar database does is it takes each column and stores them as individual columns, but only stores a unique list. So product ID is going to have 7.7 million rows, but when it gets stored in the columnar database, they're only going to store the unique items. Now, there's also a behind-the-scenes map that determines how many rows there are that it can use to reconstruct when it makes calculations. But on the storage side, our table over here that originally had over 2,000 rows, when we count all these unique lists and add them up, there's going to be 621 bits of data or cells in the columnar database. Now, this is only with a table that has 600 rows. So you can imagine with 7 million rows, that columnar database is going to compress and store it efficiently. Now let's go over to the next sheet. This is a diagram that's going to allow us to calculate the sales for a transaction. We're going to have to use the product dimension or lookup table, and we're going to have to use the fact table. So for this yellow transaction here, there were 4 units sold. The revenue discount, they only got 1.9 pennies discount for every $1. So that's why in the formula, you take the $1 minus the discount. Then in our formula, we're going to have to look up based on this foreign key on the many side product name. We're going to have to look up in the dimension or lookup table the Aspen product and then bring the price back to the formula. And that's how we'll calculate sales for every line in our table. You can look through this if you want. And this will be our formula. Since we're going to be doing it in the data model, we're going to use DAX formulas. Now, round we know how to do. Related is like XLOOKUP. XLOOKUP is more complicated when you do related to look up a product price. Because there's a relationship, you just have to say what you want. That's it. And then we multiply by, well, 1, and that's the name of the column that has the revenue discount. So that's really this part. And then times, there's the name of the column for quantity. And of course, over here, D product retail sales, that's this field from the dimension or lookup table. Now, the last thing is credentials. We're going to be logging on to an SQL database and pulling the data from online. And the great thing about storing the data online is it's not on-premise. We don't have to worry about those text files or Excel files and what the file path is. Power Query is just always going to be connected to that online database, which isn't going to move. But in order to get access, we're going to have to use these credentials: server, database, username, and password. All right, now we're going to open up a new Power BI desktop file. Our goal will be to create these 7 measures. this gross profit page, and using a map visual, we'll plot gross profit across the world. All right, we're going to start our SQL Power BI desktop adventure by opening a new file, saving it with a good name. And step one is to get the data. So we go up to Home, Data. We could go to Get Data, SQL Server, but there's a big button right here, so I'm clicking this. SQL Server Database, we have to enter our credentials. The server is pond.highline.edu tab. And the database is lowercase boom data. We're going to do a direct import, bring the data into here. Let's click OK. Be sure to say database on the left. The username is excelisfun, all lowercase. And this is where most people get in trouble. You got to spell this right with correct capitalization. Capital E, X-C-E-L, that's Excel. Capital I-S is, capital F-U-N, and an explanation point. We definitely want to connect just to server and database. Now we're going to click Connect. This is not encrypted, so we click OK. And just as in Excel, we get the Navigator window, and we get to pick amongst various objects. Do not import the D calendar table. It doesn't have the right dates. We want D country, D product, and F transactions. We do not click Load. We want to click Transform Data. Now there's three queries on the left. F transaction is selected. There's our preview. The name is perfect, and we have these two steps. Now we already reviewed these columns, and the data type should be perfect because this is coming from an SQL database, but we still have to check. And sure enough, revenue discount is not correct. So we're going to add a step, click ABC, and we definitely want decimal number as our data type. It added that step. We'll scroll over. And when you import data from a relational database, which just means there's relationships, these extra columns come in with data from the table on the other side of the relationship. We don't need any of these, so I'm going to click the first one, hold Shift, click the last one, and right-click Remove. There's a new step. The data types are right. This table is looking good. Now we click D product. Data types are all good. And this is a column with every single transaction from the F transaction table for that product. The relationship is what brings that table in. But we don't need this column, so right-click Remove. The name and the steps are fine. D country, looking good. Right-click Remove. Those are good. Now, we're going to click Close to close this and Apply to send this to the data model. But when we click, it's busy working behind the scenes, building that Columnar database. So all these millions of records will be compressed into a much smaller space. And there it is done. Now let's go look at data. And on the right, there's our tables. D country, D product, and F transactions. If we go over to model, it already put the relationships in. There's our F transaction, D country from the one to many side, our product table. We have a unique list of products from the one to many side. Now what we're going to need next is a date table. And a date table must contain a unique list of dates for every possible year from the date field in the fact table. If we go look at our tables, D country does not have a date column. D product doesn't either. And in the F transaction table, we have one single date column. And when you have only one date column in the fact table, and there's no other date columns in any of the other tables, that will allow us to create our date table in a much easier way. Now we'll create the date table in just a moment, but this is our fact table, and we use Power Query to import it into the data model. But I want you to notice that when you're in Data View and you select a column on the preview for this table, we're allowed to change the format. Now, this is the same over in Power Pivot also. I want to show this date as a short date. I don't want to see the day name. Also notice that over here in the preview and data view, you can actually change the data type on a given column. Now, when we import using Power Query, we don't want to set our data types here in the data model. We want to do it with Power Query. But in just a moment, when we create our date table, we'll have to use this feature to make sure the data type is correct. Now, let's create our date table using DAX formulas. And the way we do it is we can go over to Table Tools. And this is different than Power Pivot. Power Pivot, we can create measures and calculated columns, but we can't create tables. Here in Power BI Desktop, we're allowed to create DAX tables, and they'll be loaded to the data model. So let's create a new DAX formula to create a new table. Up in the formula bar, we type, just like over in Power Pivot, name, assignment operator, formula. The name for us is going to be ddate. And luckily, the assignment operator is just equal sign instead of Power Pivot, where we had to do :equal. So equals, and there's two calendar functions. Calendar is what you use if you have multiple date columns, and then you just specify the start and end, and it creates a unique list. But when we only have one date field in the fact table, we can use calendar auto. If you had a fiscal year, you'd put it in, but we don't. So you just don't put anything in. And when I hit Enter, it hunts through the data model, finds the min and max date, and gives you a unique list for every day for every year it found in the date column in the fact table. Now we select the date field. The automatic field name is date. We have to set the data type over here in the data model because we didn't bring this in using Power Query. We definitely want this as a date, and I'm going to format it as short date. Now, if we look over on the right, we now have a new table, and it's in the data model. Let's open. We have one field. Now, when you have a date table, you have this unique list, but then you can add as many attribute fields as you would like. If we want year and month in our reports and visuals, we have to add those to the date table. You can also add lots of other date attributes, like fiscal year, fiscal quarter, week, and many more. Now we want to go back to Table Tools because this button right here is really important for date tables. We saw this over in Power Pivot. When we mark a table as a date table, then the automatic date table creation feature is turned off. Now we saw in Power Pivot that if we dragged a date field into a pivot table, it added all these columns to the fact table. And we definitely don't want that. But over here in Power BI Desktop, it's even worse. If you drag a date field into a visual and you don't have your table marked as date, every time you do it, it creates a new hidden date table. And you can't go and look at them. So I'm going to make sure and mark this as a date table, and then tell it where the primary key or the unique list is, date. OK. Now we can add our extra fields or columns. We're going to say new column. Up in the formula bar, we definitely need month number, equal sign, and the function is the same as over in Excel, month. And we want to access, using row context, the date in each row. So I say dd, down arrow, there's the date field tab, close parentheses, and enter. Now this is the first time we've created what is called a DAX calculated column. This over here is not a DAX calculated column. This was a one-column table, but this is a DAX calculated column. We can see the formula in the formula bar. And DAX calculated columns calculate differently than Excel worksheet formulas and different than Excel table formulas. Notice up here, that's the complete column reference. If we had a column in the worksheet and used worksheet formulas, how would we access each row? We'd have to use a relative cell reference. If we were in a table column, we wouldn't have the full column reference, we'd have the field name in square brackets with an @ symbol. But over here in DAX calculated columns, and also later we'll see DAX Iterator functions, they both use a complete column reference. And then behind the scenes, it's calculated using row context. And all row context means for a full column like this is it can see each item in each row. So from now on, when we create DAX calculated columns or later iterator functions, we'll just put in the whole column reference, and row context will get the item in each row. Now, for each new column we create, we have to consider data types. Over in Column Tools, I'm going to check the data type. Now, that's fine, but it is a number. If we were to drag this into one of the reports, it would try to add them. But this is one of the fields we're going to hide. So back in Table Tools, New Column. This is going to be month. And whereas over in Excel, you use the text function to create a month name or other possibilities like day name. But over here in DAX, they decided not to call it text. They call it format. And so what format will do, we put a value in DD down arrow, tab to get the full date column. And I want to format each one, so I type a comma. There's the format argument. And then in double quotes, M means month, D means day, and Y means year. Now watch what happens, and it has to be in double quotes. But I'm going to put 1, 2, 3, 4 M's for month, end double quote, close parentheses, and enter. That will give us the full name of the month, but that's not what I want. I'm going to backspace and only put 3 M's. That will put an abbreviation, 3 letters. Now over in Column Tools, we need to check the data type. Text is fine. Also, just as in Power Pivot, this would sort alphabetically. And watch this. I'm going to go over to Report, click in the white, and all I'm going to do is check month. And when you do that, it throws it into a table. Sure enough, that's alphabetically. So we come back over to Data, and we have to tell month to be sorted by month number. So we come over to Sort by Column. And we definitely want to say sort that by month number. You don't see anything here, but over in Report View, that's sorted chronologically, exactly what we want. Back to Data. Now we can add our next date attribute field, year. We'll click New Column. Up in the formula bar, the name of this DAX calculated column will be year. And the function is the same as over in Excel, year. DD, down arrow to get the full column, tab. And when I close parentheses and hit Enter, row context sees the date in each row and gives us the year. Now data type whole number, if we accidentally drag this to the wrong place, an implicit measure would be created to add year, which isn't what we want. We could add text data type. Then it would be aligned to the left. But better than that, we can come up to Properties and say Summarization. I do not want you to summarize. So that means the whole number is fine. Now we have our date table. Now over on the right, there's our completed date table. Notice the icon for DAX calculated columns, FFX with a table. Now we go over to Model View. We grab our D date table. We'll bring it over here. And then we're going to take date, drag it over to date in the fact table. We have the 1, that's the unique list, over to the many, because we hope we have many sales for every one day. The next task is to hide columns that we don't want to appear over in Report View. Month number is only a helper column for month. So right-click, Hide in Report View. Notice that's different than over in Excel Power Pivot. Over there, it's Hide from Client Tool. In the fact table, we don't want any of the foreign keys, country code, date, and product. We also don't want any of the number fields, although we're going to use all 3 in formulas. So I'm still holding Control, and we're going to hide all of those. Remember, if we didn't hide those and left them in report view, someone might drag and drop and create an implicit measure. Right-click, hide in report view. Country code, right-click, hide. Now, we're definitely going to use retail price and standard cost in formulas, but we do not want them in report view. Select, right-click, hide in report view. We're going to use both of these over in report view. So now we've imported the data using Power Query, created the relationships, created a date table with a DAX table function, and then DAX calculated columns, and then hid the fields we don't want in report view. Now we're going to create our DAX, one DAX calculated column on the fact table, and then a bunch of DAX measures. Let's go over to Data. Select the F Transactions table. Now here's our fact table. And when we imported this table, it did not come with a field that shows us the amount of revenue or sales for each line or row in this table. We don't have a field for cost of goods sold expense either. No problem. We can create both of those. And in fact, we already saw the formula for calculating revenue before we started the project. Now I'm going to show you two ways to calculate the revenue column. One is the two-step method. The other is absolutely amazing and makes DAX unbelievable, is the one-step method. Now I'm going to show you the two-step method first because it will help us understand how the formula is working in each row. And then I'm going to show you the one-step method. Now to calculate revenue, notice we have quantity, that's how many of the product they bought, and we have their discount, but we don't have the price. Well, the price is over in the D product table. Retail price is used to calculate revenue, and standard cost is used to calculate cost of goods sold, which is how much each product cost to make. No problem. We're going to go over to F Transactions. And because there's a relationship between those two tables, and the product is listed in every row in the fact table, instead of using XLOOKUP, we just use the DAX lookup function related. Now we definitely want a new column. And we're going to call this line because we're going to have two revenue formulas, one totaling it up, and this one is to calculate the line or row revenue. And I'm going to indicate the $sign, equal sign, and we're going to build this formula one part at a time. Right now, all I want to do is look up the price for each row in this table. Let's use related. And notice all it says is give me the column name. If I put D product and retail price here, because there's a relationship, this lookup function knows whenever it sees by row context the product to just get the right price. Close parentheses, and when I hit enter, row context gives us the price in each row. Now, this table is so big, if you try to scroll down and find a different product, you're not going to do it. But remember the magic of filters we learned at the beginning of this video. If you click, it'll give you a unique list. And sure enough, this field or column has that many different prices. I'm going to click Cancel. Now the next thing we need, if we have the price, is the quantity or the number of units purchased. So up in the formula bar, times, and we actually just can put the full column reference. So it's from F transaction, and there's quantity. Again, this is the full column, but row context will pull the quantity out from each row. When I hit enter, that's the amount of the revenue without the discount. Now they give our discount in terms of number of pennies for every $1. So we want the amount they pay. So times, in parentheses, there's the $1. And please subtract whatever the discount is, F transaction, and then revenue discount. Close parentheses. And this is the formula, enter, that gives us the line revenue after the discount. Now, down below, there are some definite decimals that we need to round. So before related, we use round. We learned round in an earlier video. At the end, comma, 2, because we're going to the penny, close parentheses, and enter. And that is our DAX calculated column formula. Now, if we look over at the F transaction, there's the calculated column. Now, when we created the calculated column line revenue, we can see it up here. Here's the column. That's step 1. Now we need to create a measure to add this entire column so we can use that measure over in report view. Now, there's a few places that you can create measures. If you already are somewhere in the table where you want the measure to appear, you can come over to Table Tools, New Measure. But since you always have to make sure that you have the right table selected, I got in the habit of, because I usually have to come over and select the table and then create the measure, I just click on the table and right-click. New Measure is right at the top. Up in the formula bar, we're going to call this measure Total Revenue. And I'm actually going to add the function name sum to this, because in this measure, we're going to use the sum function. In our one-step method later, we'll use just total revenue, and that's the formula we'll use over in report view. But inside of sum, FT, that's the F transaction table, and guess what? I get to use my calculated column. So 2 steps. Create calculated column, and then create measure to aggregate. When I hit enter, this measure will add this whole field. We also could have used other aggregate functions like average, min, or max. Now, I do want to add some formatting to this measure. So when we drop it in the visual, it has the right formatting. Now, in Power BI Desktop in Data or Table View, we cannot see the result of the measure. We see the measure down here. So what I usually do is I come over to Report View. We don't need this anymore, so I'm going to delete. I'm going to select a table and then resize it. As I create each measure, I'm going to show it here in the report area to make sure it's calculating the right result. And I'm going to add 1 field, so that way I can see how the measure is working across the fields, and it will calculate the total at the bottom. I'm going to check total revenue. And bam, there it is. The 2-step method. We created the DAX calculated column, the measure, and there's all the revenue for the product with the grand total at the bottom. If we were over in Power Pivot, right, we would see the grand total in the measure grid. But over here in Power BI Desktop, when you are in Data or Table View, we don't have a measure grid. So that was the 2-step method. Now we get to see the amazing 1-step method. Now, remember what we did with the 2-step method. Here's the F transaction table, and we attached to the side of the F transaction table a calculated column. Then we created a second formula, a measure, to add. Well, in the 1-step method, we're going to use an amazing iterator function that simulates row-by-row calculation called SUMX. And in the first argument of SUMX, you just say, hey, which table would you have put the calculated column? So the first argument will have F transactions. And then you put the exact same formula, and I'm going to copy this, in the second argument of SUMX. And then SUMX does both steps. Inside the formula, it'll actually calculate all 7 million values as if we had a calculated column. That's the X part, the iterator part. And then the sum part adds all 7 million rows to get total revenue. Now I'm going to hit enter, come over to F transaction, right-click, new measure. Total revenue equals sign. The sum part will add, the X part will iterate, and look at the arguments. All it wants, the table to iterate down, and whatever formula you would have put into a calculated column. F transaction. That's the table. Comma. Expression is a synonym for formula. In this case, a calculated column. Control V. When I close parentheses, enter. Add some formatting. Come over to Report View. The table is selected. I check total revenue. And you got to be kidding me. The exact same thing. But with the one-step method, we did not have to add that calculated column. Now the difference between these two methods, let's go back to data or table view. With the two-step method, when you create a calculated column, these values are stored in the Columnar database. That means it will take more storage space in the Columnar database. But these values are only calculated when you create the column or when you refresh the table. Each individual value is not calculated over in report view when we drag and drop the sum measure into reports or visuals. With the one-step method, you don't have to store anything in the Columnar database, so it doesn't require extra storage space. But every single value in this measure right here, that's this entire 7 million row column, all those values are calculated inside the formula every time you drop it into a visual or report, or when you change the conditions or criteria. So which method should you use? Well, it's really up to preference. As the great DAX masters Alberto Ferrari and Marco Russo say, 100 million rows or less, and there's not much performance difference. Now the rule I use is this. In report view, now I'm going to uncheck both measures. And performance just means how fast does the measure calculate and get the answer. So we're going to add both measures and watch to see, is one faster than the other. So I'm going to check the two-step method first. So check. Well, that was fast. Now let's do the one-step method. Well, that was fast. They look exactly the same. And my rule is this. If I start dragging and dropping a one-step method and it's calculating too slowly, that means there's some calculation-intensive steps in the formula, and I might want to move it over to a column. What that would do is allow it to calculate one time when we refresh or create the column, and then it wouldn't have to recalculate each time we use it in report view. But again, if you only have 7 million rows like we have, it's probably not going to matter which method you use. Now, there are ways to measure speed. There's a method inside of Power BI Desktop, and there's also a program called DAX Studio. With those tools, you can measure performance. But we're not going to need to do that in this class. But again, most of the time, it doesn't matter. Now, I'm going to drag this over here, and I'm going to name this page Test Calculations. And now we have 4 more measures to create. Now, you can create measures in table view or report view. The advantage of doing it in report view with an extra sheet like this is as soon as you calculate it, you can see the result. So we'll pretend that this is our measure grid like over in Power Pivot. Now, I'm going to go over to F Transactions, right-click New Measure. Up in the formula bar, we're going to create the total cost of goods sold one-step measure. This measure here is going to be similar to our total revenue. We need to calculate every line item cost of goods sold in the fact table and then add. That means we use SUMX. The table, of course, is our fact table, F Transactions, comma. And expression is the formula we would use in a calculated column. Now, we're going to have to round each amount. We're going to have to look up the standard cost from the D product table, and then from the F transaction table, whatever the quantity total units is, and the net cost equivalent. So I'm going to type round. To get the price, we're going to use related. But wait a second. I thought related had to see each row in the fact table. Well, when you're using SUMX, remember this is exactly like a calculated column. So when we put D product, standard cost, close parentheses, that related will see every single row in F transaction. Of course, it will see the product in every single row. And through the relationship, it'll go and get the standard cost. So we have our cost times F transaction, quantity times F transaction net standard cost. Now, this is not the discount. When you have a discount, you have to do 1 minus. When you have net cost, they already made that 1 minus or plus calculation for you. So in the formula, we just use that column. Now, that's the formula for round. Now, we can look at the screen tip to help us because we're a couple functions deep, comma, number of digits to round to, 2. Now, watch when I close parentheses. Round is completed. That's the expression or the calculated column. Now I have to close off SUMX. When I hit Enter, add some formatting, and come over and check total cost of goods sold. Bam! There's our total cost of goods sold for each product and the grand total at the bottom. Now our fourth measure we want to calculate is a metric called gross profit. And gross profit is revenue minus cost of goods sold. Manufacturers and retailers like this metric because it takes the total revenue minus the total cost for the product. Cost of goods sold does not include all the other expenses in the business. It's revenue minus the single expense, cost of goods sold. So for example, this is a Boomerang manufacturing company. There's a Gel Fast. There's wood, paint, sandpaper, machine maintenance, packaging, instructions, and maybe some other things also. All of those together make up the single cost of goods sold expense. So when we subtract these two things, it gives us gross profit, sometimes called contribution margin. That means the amount left over to cover other expenses and profit. So we right-click F transaction, new measure. We'll call it gross profit. And wait a second, we get to take one measure already created minus another. Now watch this. We're not going to include the table name, square brackets, and the measure. That convention is reserved only for columns. When we type a square bracket, the DAX engine knows the convention is to use square brackets only for measures. So we can down arrow to get total revenue, tab, minus square bracket. I see total cost of goods sold, so tab. That's our formula. Enter. I better add Enter. Some number formatting. Now I'm going to come over and check gross profit. And so for the Alpine product, the gross profit was $32 million. Now, an even better metric is to take gross profit as a numerator, total revenue as the denominator, and then that's called gross profit percentage. That tells you how many pennies for every $1 are left over for gross profit, which is all other expenses and profit. So right-click, new measure, and instead of using the division operator in DAX, we can use the divide function. It needs a numerator, so square brackets, and that's going to be gross profit, comma. It needs a denominator, square bracket, the measure total revenue. Now we could comma and put alternative result. That's what you put in the cell if there's a divide by zero error. If you leave this omitted, meaning just close parentheses, then if there is a divide by zero error, in the report, it'll look like an empty cell. Close parentheses, enter. Now this is going to be a percentage, so we'll add percent number formatting. I want 2 decimals. I can come over and check. And so Crested Butte has 37% gross profit. So for every $1, 37 pennies are left over for gross profit. Whereas Carlota Doublers, much higher gross profit percentage. Now the last measure we need is total units. And we have a quantity column in our fact table. So right-click, new measure, total units, no $sign because this is counting. Sum, F transaction, and down to quantity. That's the number of units sold for each transaction. Close parentheses, enter. And I'm going to do comma. We definitely want 0 decimals because this is counting. We come over and check total units. And there's our last measure. And now let's go over to Model to admire our handiwork. F transactions. There's a bunch of measures. We have our hidden columns, our one column where we might pull into a report, the dimension tables, calculated table, calculated columns, and hidden fields. Now, oftentimes, the hard work is creating the data model, but getting this correct makes all that visualizing and reporting and sharing easy and effective. Now we can go over to Report View. We're going to add a new sheet. Gross profit report. I'm going to click in the white. We want a line chart. We'll put this down at the bottom. We'll put year in the X, month below year, and we want 3 lines in our chart. We definitely want to see total revenue, total cost of goods sold, and percent gross profit. Now, anytime you have a measure like this is a teeny number between 1 and 0. These are huge million or billion-dollar numbers. So when that happens, we come over to the measure in the y-axis. Click the drop-down. Move to secondary y-axis. We could see the label here and the 2 labels over here. We definitely want to bring this down 2 levels and show year and month. Over in Format, x-axis, we don't want to concatenate. That's looking much better. In general, I don't want to see a title. That label, this label, everything's looking good. Really, a chart like this is a lot easier in Power BI Desktop than it is over in Excel. Now, I hit pause and created this second visual, a stacked bar with category in the y-axis and product in the legend, and gross profit. Now, we finished this gross profit page, and if we look at this line chart, we can notice some patterns. It looks like we have a seasonal pattern. Christmas time, Christmas time, Christmas time's always up. And over time, the Christmas sales are getting bigger and bigger. We can also see the pattern, and this is probably not very good. And this is the gross profit percentage for all products together. But over the years, the trend is down. So from about 44 down to 40. That means over the 4 years, if gross profit percentage goes down, they have less left over to cover other expenses and products. Now, if we come up here, if we want to look at how this chart changes by beginner, we can. Competition, it looks like different specifics, but the overall pattern is still the same. The seasonal is Christmas, and it looks to be going up over time, and gross profit percentage down over time. Now we can unfilter. We want to create one more page. We're going to call this page GP Map. Enter. We click in the white, and we're going to see this amazing visual, a world map. And it'll show the whole world. Now, oftentimes, data sets will have longitude and latitude. We don't have that here. But it does understand descriptions or names like city, state, or country. We have sales all over the world, and we have country. So if we drag that down to location, immediately those dots show up. They're all the same size, but we want to look at gross profit. So we'll drag this to bubble size, and instantly we can see the bubbles all have different sizes. Now, the funny thing is, you would think that Australia would have a huge bubble, but it doesn't. It looks like the United States has a big one. Over here, this is Europe. If you hover, Germany looks like it has a big one. Japan, too. And France has a big one. And in fact, it's August 20th when I'm filming this video. And right now over in France, there is a 10-day world championship of boomerang throwing. USA has a couple of teams, certainly France, Germany, Japan, and Brazil. So there's our map for comparing a particular metric. All right, so we did one page with a map. We did a gross profit report. We had one page where we tested all of our measures. And in model, there's our data model. Now, we're not going to publish this and share this. And in fact, the main thing we learned in this example is how to import big data and build a data model over here in Power BI Desktop. Now, that was the most epic video I have ever made. 3.5 hours. Your one-stop shopping for Excel and Power BI data analysis. We covered all of these topics so you can become awesome and have fun with efficiency using Excel and Power BI. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from Excel is Fun. All right, we'll see you next video.